There is a moment deep in the fossil record when the story of life on this planet takes a turn that most people never expect. A turn that challenges everything we think we know about which animals ruled the earth, which creatures held dominion over vast and sweeping landscapes, and what it truly means to be a predator at the very top of a food chain. Most of us, when we imagine the great hunters of prehistoric times, picture saber-toothed cats with their enormous curving fangs, or massive wolves prowling through frozen tundra, or perhaps the enormous dinosaurs that shook the ground with every step. We think of mammals and reptiles as the natural rulers of a wild and ancient world. But there is a chapter in the history of life that gets far less attention than it deserves, a chapter written not in the bones of mammals or the scales of reptiles, but in the hollow, lightweight skeleton of something that walked on two legs, something that wore feathers, and something that, for tens of millions of years, was the most feared creature across an entire continent. These were the terror birds. And before you let that name conjure images of something merely large or vaguely threatening, understand that these animals were extraordinary in every sense of the word. They were not simply big birds that happened to be dangerous. They were the culmination of millions of years of evolutionary refinement, shaped by the pressures of an isolated world into something that functioned as the apex predator across one of the most biologically unique landmasses the Earth has ever produced. They were fast. They were powerful. They were intelligent enough to pursue, corner, and kill prey that was in many cases significantly larger than themselves. And they did this not for a few thousand years, not even for a few 100,000 years, but for a stretch of time so vast that it dwarfs the entire history of human civilization by a factor that is almost impossible to comprehend. The terror birds ruled for tens of millions of years, and then they were gone. But the story of how they rose, how they thrived, and ultimately how they vanished is not the simple story of a creature that was simply outcompeted or overwhelmed by something bigger and stronger. It is a far more nuanced, far more layered, and far more philosophically rich story than that. It is a story about isolation and connection. It is a story about specialization and adaptability. It is a story about the nature of dominance itself, about what it means to be perfectly suited for a world that is always, at some fundamental level, in the process of becoming something else. It is a story about how the very qualities that make a creature extraordinary in one context can become the seeds of its eventual undoing when that context begins to shift. It is, in many ways, a story about all of us, but we are getting ahead of ourselves. To truly understand the terror birds, to feel the weight of what they were, and what they represented in the grand tapestry of life on this planet, we need to go back. We need to go back not just millions of years, but to a time when the Earth itself was arranged so differently from the world we know today that it would be almost unrecognizable to modern eyes. We need to understand the stage before we can understand the players. We need to understand the world that made the terror birds possible, because that world was unlike anything that exists today, and the creatures it produced were unlike anything that followed. So let us begin at the beginning. Let us begin with a continent adrift. Picture the Earth as it existed roughly 66 million years ago, in the immediate aftermath of the mass extinction event that ended the reign of the non-avian dinosaurs. The great impact, or whatever combination of catastrophic events it was that brought the Mesozoic era to its close, had swept the slate of large terrestrial predators almost entirely clean. The tyrannosaurs were gone, the ceratopsians were gone, the long-necked sauropods that had grazed on the canopies of ancient forests were gone. The world, in the immediate aftermath of this extinction, was a quieter, smaller, more tentative place. The creatures that survived were largely those that could hide, those that could burrow, those that could find shelter in water or in the soil, those that were small enough that they did not require enormous quantities of food to sustain themselves through the dark, cold years that followed the catastrophe. Among those survivors were the ancestors of the birds, and here is something that many people find genuinely surprising. The birds of today are, in the strictest biological sense, avian dinosaurs. They are the descendants of theropod dinosaurs, the same broad group of bipedal, often feathered dinosaurs that includes the famous velociraptor, and at the very apex, the Tyrannosaurus rex. The birds did not just survive the extinction event that ended the age of dinosaurs. They survived it as dinosaurs, carrying forward in their biology the heritage of one of the most successful and diverse groups of animals that has ever lived on this planet. And in the aftermath of that extinction, with the great mammalian predators not yet evolved into the powerful forms they would eventually take, with the world essentially open and waiting for something to step into the ecological roles that had been vacated, the birds had an opportunity. Not all birds, of course. The small, seed-eating, tree-perching ancestors of modern songbirds were not going to fill the role of apex predator. But some lineages of birds in some parts of the world were in a position to do something remarkable. They were in a position to grow, to become larger, more powerful, more dangerous, to reclaim, in a sense, the ecological legacy of the great bipedal hunters that had preceded them. This is where South America enters the story, and South America, at this point in geological history, was not the continent it is today. It was an island. A massive island, certainly, a landmass of enormous size and extraordinary biological richness, but an island nonetheless, separated from the other great landmasses of the world by vast stretches of open ocean. This isolation was not a recent development. It was not a temporary condition. It was a state of affairs that would persist for tens of millions of years, a geological fact as fundamental to the history of life in that part of the world as the presence of the Andes Mountains or the Amazon River. And isolation, in evolutionary terms, is one of the most powerful forces that exists. When a population of animals is cut off from the rest of the world, when it cannot exchange individuals with other populations, when it cannot receive the genetic material, the new adaptations, the new strategies that arise elsewhere, it is forced to work with what it has. It is forced to evolve in response to the specific pressures of its specific environment, uninfluenced by the developments happening on the other side of an ocean it cannot cross. This can lead to the evolution of creatures that are found nowhere else on Earth, creatures that represent unique evolutionary solutions to the problems of survival, creatures that are, in their own way, experiments in what life can become when given enough time and enough freedom from outside influence. South America, during its long period of isolation, became one of the greatest of these experiments. The creatures that evolved there were extraordinary in their diversity, in their specialization, and in their strangeness. There were mammals unlike any that existed anywhere else on Earth. There were reptiles that filled ecological roles typically occupied by other types of animals elsewhere. And there were, rising to prominence in the open grasslands and lightly wooded plains that spread across much of the continent, the birds that would eventually be classified as Phorusrhacidae, the terror birds. The name Phorusrhacidae comes from the Greek, meaning roughly something like bearing wrinkles or rag bearer, a somewhat anticlimactic name for creatures of such power and presence. They are also sometimes referred to by the more common name that has been applied to them in popular science literature, terror birds, a name that, whatever its lack of scientific precision, captures something essential about what these animals were in their world. The terror birds were not a single species, but a family of birds, a diverse group of related species that lived across an enormous span of time and across a wide range of environments, from open grasslands to the edges of forests, from warmer tropical regions to cooler temperate zones. The earliest terror birds appeared roughly 60 to 62 million years ago, in the early Paleocene epoch, not long after the great extinction event that ended the Mesozoic era. From those early beginnings, they would diversify and evolve over the following tens of millions of years, eventually producing species of extraordinary size and power before their lineage finally came to an end somewhere in the neighborhood of 2 to 3 million years ago. That is a run of roughly 60 million years. For perspective, the entire history of the hominid lineage, the evolutionary line that eventually produced modern humans, spans only about 6 to 7 million years. The entire genus Homo, the group that includes our own species, has existed for only about 3 million years. The terror birds were alive and hunting in South America before our distant ape-like ancestors had even begun to walk upright on the savannas of a completely different continent. To understand what made the terror birds such effective predators, we need to talk about their anatomy, because their bodies were extraordinary pieces of biological engineering, shaped over millions of years into something almost perfectly suited for the hunting lifestyle they had adopted. Start with their size. The terror birds varied considerably in size across different species and across the enormous span of time they existed. The smallest members of the family were significantly smaller than the largest, and not all species were the giants that tend to dominate popular depictions of these animals. But the largest species, those at the upper end of the size range, were formidable in their dimensions. The largest known terror bird, a species called Kelenken guillermoy, which was discovered in Patagonia and lived approximately 15 million years ago, stood somewhere in the neighborhood of 3 meters tall, or roughly 10 feet in height, and is estimated to have weighed in the range of 250 kilograms, or about 550 pounds. Its skull alone was nearly 90 centimeters long, making it one of the largest bird skulls ever recorded from any species, living or extinct. But even among the more typical-sized terror birds, which might stand somewhere between 1.5 and 2 meters tall, the effect of encountering such an animal would have been overwhelming. These were not creatures you would see at a distance and dismiss. They were birds that filled your field of vision, that blocked out the horizon with their sheer physical presence. Standing at roughly the height of an adult human, or often significantly taller, they would have been impossible to overlook and impossible to underestimate. Their most immediately striking feature, the one that draws the eye in any artistic reconstruction or skeletal display, was their head and beak. The terror birds had massive skulls that were deep and laterally compressed, meaning they were tall and somewhat narrow when viewed from the front. The beak was enormous relative to even the already large skull, deeply curved at the tip, strongly hooked in the manner of a bird of prey, but scaled up to a degree that goes well beyond anything in the modern avian world. The hook at the tip of the upper mandible was not merely a feature for gripping prey. It was a weapon, a tool for delivering precise, powerful strikes to specific targets. Paleontologists who have studied the biomechanics of terror bird skulls have found that, while the skull was not particularly well suited for the side-to-side twisting motion that predators like crocodiles and large canines use to dismember prey, it was extraordinarily well suited for powerful vertical strikes, for driving the tip of that hooked beak downward with tremendous force. This tells us something very important about how these animals hunted. They were not the kind of predators that grabbed their prey and shook it, or that wrestled it to the ground through sheer mass. They were precision strikers. They used their speed to close the distance to their prey, and then they used their beak as a weapon of concentrated, targeted force. Biomechanical analyses suggest that the terror birds likely delivered rapid, powerful blows to the heads and necks of their prey, essentially bludgeoning or piercing vulnerable anatomy with surgical precision. Some researchers have compared the motion to that of a hatchet being swung downward, the beak acting not as a grabbing tool but as a striking instrument of remarkable power. Their legs were built to match this hunting strategy. The terror birds had long, powerful legs that were clearly adapted for speed. The proportions of their leg bones, particularly the elongated tibiotarsus and tarsometatarsus, are characteristic of birds built for rapid locomotion. Estimates of their running speed vary depending on the species and the methodology used to calculate it, but there is general agreement among paleontologists that the medium to large-sized terror birds were capable of reaching speeds that would have made them formidable pursuit predators. Some estimates place their top speed in the range of 48 to 60 kilometers per hour, or roughly 30 to 37 miles per hour, which is significantly faster than a human sprinter and comparable to the speeds achieved by many modern large mammals. Their feet were equipped with powerful talons, though the talons of most terror bird species appear to have been somewhat less raptorial than those of modern birds of prey like eagles and hawks. The terror birds may have used their feet primarily for gripping and pinning prey rather than for the initial killing strike, relying instead on their beaks for the most decisive blows. Their wings were vestigial, reduced to small, essentially non-functional appendages over millions of years of flightless evolution. This is a common pattern among large flightless birds, where the metabolic cost of maintaining large, powerful wings is simply not worth the benefit when the animal has no need or ability to fly. The energy that would have gone into sustaining and moving large flight muscles could instead be redirected into the muscles of the legs and other anatomical systems more directly relevant to a terrestrial hunting lifestyle. One of the fascinating aspects of terror bird anatomy is what it tells us about the relationship between form and function, about the way that evolution shapes bodies in response to the demands of a particular lifestyle in a particular environment. The terror birds were not simply large birds that happened to eat meat. They were animals whose entire body plan had been refined over tens of millions of years into something exquisitely suited for a specific kind of predation in a specific kind of environment. Every feature of their anatomy, from the shape of their skull to the proportions of their leg bones to the reduced wings that balanced their running stride, reflected the demands of hunting in open landscapes where speed, precision, and power were the currencies of survival. And the environment they evolved in was, for a very long time, almost perfectly suited to creatures with exactly these capabilities. To understand why the terror birds thrived for so long and so successfully, we need to understand the environment that sustained them, the ecological context in which they evolved and which they in turn helped to shape. And that environment was, at its most fundamental level, defined by two interrelated facts: the geography of South America during its long period of isolation and the nature of the ecosystems that developed within that isolated landmass. South America's isolation from the rest of the world's landmasses meant that the evolutionary story playing out on that continent was largely independent of the story unfolding elsewhere. On other continents, the mammalian lineages that had survived the end Cretaceous extinction were diversifying rapidly, filling ecological roles that had been vacated by the non-avian dinosaurs. Large mammalian carnivores were evolving in North America, Europe, and Asia, gradually developing into the powerful, sophisticated hunters that would eventually dominate those regions. The ancestral lineages of wolves, big cats, bears, and hyenas were taking their first evolutionary steps toward the ecological dominance they would eventually achieve. But in South America, this process was happening differently. The mammals that populated isolated South America were extraordinary in their diversity, but belonged to lineages that were very different from those evolving elsewhere. There were the ungulates, large plant-eating mammals that filled some of the ecological roles played by horses, rhinoceroses, and cattle on other continents. There were the litopterns, another group of South American ungulates that in some cases converged strikingly on the form of horses, developing long legs and reduced toes in a remarkable example of convergent evolution. There were the enormous ground sloths and their relatives, the xenarthrans, which included forms ranging from small burrowing insectivores to the gigantic megatherium that would eventually grow to the size of elephants. There were the native South American marsupials, including some lineages that occupied ecological roles similar to those of placental carnivores elsewhere. But large, powerful, purely terrestrial mammalian predators of the type that dominated other continents were largely absent from South America during much of the terror bird's reign. The mammalian carnivores that existed in isolated South America were generally smaller, less powerful, and less ecologically dominant than their counterparts on other landmasses. Some of the marsupial carnivores reached reasonable sizes and were certainly effective predators within their own ecological niches. But they were not, for the most part, the kind of large, powerful apex predators that could directly compete with the terror birds for dominance at the top of the food chain. This absence of large, competitive mammalian predators was perhaps the single most important ecological fact in the terror birds' long history of success. In a world where no other creature could effectively challenge them for the top position in the food web, the terror birds were free to develop, to diversify, and to perfect their hunting strategies across millions of years without the constant pressure of serious competition from comparably powerful rivals. They were, in a very real sense, the unchallenged lords of their domain, and their domain was a vast and resource-rich continent that provided them with everything they needed to maintain that dominance. The landscapes they inhabited were varied but tended toward the open. The great grasslands and savanna-like environments that developed across much of South America during the Miocene epoch, roughly 23 to 5 million years ago, were particularly well suited to the terror birds' hunting style. Open environments offered what the terror birds needed most: visibility, space to run, and the opportunity to identify and pursue prey over meaningful distances. These were not predators built for the dense, tangled undergrowth of deep forests, where ambush and concealment would have been more valuable than speed and pursuit. They were creatures of the open country, and the open country of South America was, for millions of years, abundant and spreading. The Miocene was a particularly important period in the history of terror birds because it was during this epoch that the grasslands that would become such a dominant feature of South American landscapes really began to develop and spread. Grasses, which had evolved earlier but had not yet become a dominant form of vegetation, began to spread across vast areas during the Miocene, transforming the landscape and creating new ecological opportunities. These spreading grasslands supported large populations of herbivorous animals, which in turn supported predators. The terror birds, already well established as the dominant large predators of the continent, were ideally positioned to take advantage of this expanding ecological resource. And here we encounter one of the most fascinating aspects of the terror birds' ecological role: their relationship with their prey. The prey animals of South America during the terror birds' long reign were themselves the products of tens of millions of years of evolution in isolation, and they were shaped in part by the constant pressure of predation from the terror birds. This is one of the fundamental dynamics of predator-prey relationships in ecology. The predators and the prey evolved together, each side of the relationship exerting selective pressure on the other in a continuous evolutionary dialogue that shapes both the hunter and the hunted over deep time. The prey animals of South America developed their own suite of survival strategies in response to the threat posed by the terror birds. Speed was one obvious response, and many of the herbivorous mammals of South America were remarkable runners. The Litopterns, for example, evolved horse-like forms that were clearly built for rapid locomotion. The Macraucheniids, another group of native South American ungulates, had long legs and a body plan that suggests they were capable runners. These animals were not simply passive victims of terror bird predation. They were the other half of an evolutionary arms race, constantly evolving better evasion strategies in response to the selection pressure imposed by the presence of large, fast, powerful avian predators. This predator-prey dynamic is one of the great engines of evolutionary change in the history of life. It is not a static relationship but a constantly shifting one, with each improvement in predatory capability driving a corresponding improvement in prey evasion, and vice versa. The terror birds and their prey were engaged in this dynamic across enormous spans of time, and the result was an ecosystem of remarkable complexity and balance. Not a peaceful ecosystem, of course, not a gentle or forgiving one, but a balanced one in the sense that it had achieved a kind of ecological equilibrium in which the terror birds occupied their position at the top of the food web, and the prey animals had developed the strategies and behaviors necessary to minimize, though never eliminate, the risk of predation. The terror birds were not indiscriminate hunters. Like all sophisticated predators, they were selective, targeting prey that was vulnerable, prey that was young or old or sick or isolated, prey that could be caught and killed without excessive risk to the predator itself. This selectivity is not a sign of weakness but of intelligence, of the kind of behavioral sophistication that characterizes apex predators across many different taxa. The terror birds were not simply biological machines programmed to attack anything in sight. They were hunters that made choices, that assessed opportunities and risks, that employed strategies and tactics in pursuit of their prey. What did those strategies look like? Here we must be careful because we cannot observe terror birds hunting, and the behavioral evidence that can be recovered from fossils is always indirect and often fragmentary. But we can reason from what we know about their anatomy, their environment, and the behavior of modern large predatory birds to construct a reasonable picture of how they might have hunted. The combination of long, powerful legs built for speed, a beak designed for powerful downward strikes, and eyes positioned to give good forward-facing vision suggests that the terror birds were likely pursuit predators, animals that used their speed to chase prey and their beak to deliver killing blows once they had closed the distance. This is consistent with the open landscape environments they inhabited, where pursuit predation is generally more viable than ambush predation. In open grasslands, where prey can see the predator from a long distance and the predator can see the prey equally well, the advantage goes to the animal that can outrun or outmaneuver the other. The terror birds, with their long legs and high running speeds, were well equipped for this kind of hunting. Some researchers have suggested that the terror birds may also have used their large, powerful feet to stun or immobilize prey before delivering killing blows with their beak. The large claws, while not as strongly curved and raptorial as those of modern eagles or hawks, would have been effective tools for pinning prey to the ground or delivering powerful kicks. The combination of kicks with the feet and strikes with the beak might have been particularly effective against medium-sized prey, animals large enough to require significant effort to subdue, but small enough that a single, well-placed strike from that enormous hooked beak could be decisive. There is also the question of whether the terror birds were solitary hunters or whether they might have hunted cooperatively. Modern ratites, the group of large flightless birds that includes ostriches, emus, rheas, and cassowaries, do not generally hunt cooperatively, but they also are not primarily predators in the way that the terror birds clearly were. The closest modern analogs for social hunting among birds are found among some raptors, particularly certain hawks and falcons, but these are generally much smaller animals, and their social hunting strategies are quite different from what we might imagine for the terror birds. It is genuinely uncertain whether terror birds ever cooperated in hunting, and without behavioral evidence preserved in the fossil record, it is difficult to say with any confidence. What we can say is that the anatomy of the terror birds was well suited for individual hunting of prey of a certain size range, and that the environments they inhabited would have supported this kind of solitary predation strategy effectively. Whether they ever formed hunting groups, whether there was any social structure to their populations beyond the basic requirements of reproduction, remains a fascinating open question. What is not open to question is the effectiveness of whatever hunting strategies the terror birds employed, because the evidence for that effectiveness is written in their long survival as the dominant predators of their continent. 60 million years of ecological dominance is not achieved by creatures that are merely adequate at what they do. It is achieved by creatures that are extraordinarily good at it, creatures whose capabilities are well matched to the demands of their environment and whose strategies allow them to consistently find, pursue, and kill the prey they need to survive. Let us talk for a moment about diversity within the terror bird family, because the Phorusrhacidae were not a single, monolithic type of animal. They were a family in the biological sense, a group of related species that shared certain fundamental characteristics, but that also varied considerably in size, in the details of their anatomy, and presumably in the precise ecological roles they played in the specific prey they targeted. The family Phorusrhacidae is typically divided into several subfamilies, each containing species that were somewhat different from one another in significant ways. At the largest end of the size spectrum were the species belonging to the subfamily Phorusrhacidae, which includes some of the most famous and iconic terror birds. These were the giants, the animals like Phorusrhaco's longissimus itself, the species that gave the family its name, and Kelenkin guillermoi, the largest known terror bird. These were animals of impressive proportions, capable of taking large prey and clearly positioned at the very apex of their ecosystem's food webs. The subfamily Patagornithini included somewhat smaller terror birds, though still large by any modern standard. These may have occupied slightly different ecological niches from the giant Phorusrhacians, perhaps targeting smaller or different prey, perhaps inhabiting different microhabitats within the broader landscape. The subfamily Brontornithini included some of the most robust terror birds, animals that were more heavily built than many of their relatives, with proportionally shorter legs relative to their body size. These heavier animals may have relied more on power than on pure speed in their hunting, perhaps targeting larger, slower prey that required brute force rather than the kind of high-speed pursuit associated with the longer-legged species. At the smaller end of the size spectrum within the terror bird family were species belonging to genera like Coelopterus, which were significantly smaller than the famous giants and may have targeted prey that was correspondingly smaller in size. These smaller terror birds demonstrate that the family's ecological success was not solely about being the largest and most powerful animal in the landscape. It was about occupying ecological niches effectively across a range of body sizes and hunting strategies, about filling multiple positions in the food web rather than simply dominating the very top. This diversity within the family is important for understanding the terror bird's long-term success. Ecological resilience, the ability of a group of organisms to persist through environmental changes and challenges, is often related to diversity. A family of predators that exists in only a single form, targeting only a single type of prey in only a single type of environment, is vulnerable to any disruption that affects that specific prey or that specific environment. But a family of predators that has diversified into multiple ecological niches, that can target a range of prey types and that can inhabit a range of environments, is much better positioned to weather the kinds of changes and disruptions that inevitably occur over geological timescales. The terror birds were, for most of their long history, a diverse and ecologically flexible family. They were not perfectly specialized for a single narrow niche, but were capable of exploiting a range of resources across a range of environments. This diversity was part of what made them so successful for so long. But diversity within a family does not mean infinite adaptability. Even a diverse group of predators can have certain fundamental requirements, certain ecological conditions without which it cannot thrive. And as we will see, the terror birds did have such requirements, conditions that were met for tens of millions of years in the isolated world of South America, but that began to be undermined as that world changed. Understanding what those conditions were is essential to understanding not just how the terror birds thrived, but ultimately how and why they declined. To appreciate the ecological dominance of the terror birds, it helps to think about what apex predation actually means in the context of an ecosystem, and how it shapes not just the predator itself, but the entire community of organisms with which it interacts. An apex predator is more than just the animal at the top of the food web. It is a keystone species, a creature whose influence on the ecosystem extends far beyond what its simple presence or absence might suggest. The removal of an apex predator from an ecosystem does not simply mean that prey populations go unchecked. It triggers a cascade of changes that ripple through the entire biological community, affecting herbivore behavior, plant communities, water systems, and ultimately the physical landscape itself. This is the principle that ecologists call a trophic cascade, and it is one of the most profound demonstrations of how deeply interconnected living systems are. The terror birds, as the dominant apex predators of South America for tens of millions of years, were almost certainly keystone species in this sense. Their presence shaped the behavior, the distribution, and the evolution of the prey animals they hunted. Prey animals that were consistently hunted by the terror birds would have been under constant selective pressure to become faster, more alert, better camouflaged, or more socially organized in ways that improved their survival prospects. The vigilance behaviors of modern prey animals, the tendency of herbivores to be alert, easily startled, and likely to flee at the first sign of danger, are the evolutionary legacy of long exposure to predation pressure. The terror birds' hunting patterns would also have influenced where prey animals went and when they moved. Prey animals in open environments tend to avoid areas where predator density is high, or to concentrate their movements during times of day when predators are less active. These behavioral responses to predation risk have effects on plant communities, because herbivores that avoid certain areas will allow the vegetation in those areas to grow more densely, while areas that herbivores favor will be more heavily grazed. In this way, the terror bird's presence and behavior had indirect effects on the plant communities of South America, effects that were felt throughout the ecosystem, even by organisms that never directly encountered a terror bird. There is also the role of the apex predator in controlling prey populations. By consistently removing individuals from prey populations, predators prevent those populations from growing to the point where they would overexploit their food resources. A world without apex predators is not necessarily a world of abundant prey animals enjoying an untroubled existence. It can be a world of boom and bust population cycles, where herbivore populations explode until they exhaust their food supply and then crash catastrophically. The presence of apex predators tends to stabilize these dynamics, keeping prey populations at levels that can be sustained by the available resources. The terror birds, by hunting the herbivores of South America across millions of years, were performing this essential ecological service, maintaining the health and stability of the ecosystem as a whole. The ecological role of the terror birds was not merely that of a consumer at the top of the food chain. It was that of a regulator, a shaping force, a presence whose influence was felt at every level of the biological community. This is what true ecological dominance looks like, not just the ability to kill and eat other animals, but the power to shape the world in which you live through the cascading effects of your presence, your behavior, and your evolutionary influence on the organisms around you. And for tens of millions of years, the terror birds exercised this kind of dominance over the ecosystems of South America in a way that was essentially unchallenged. But the world was changing. It was always changing. That is perhaps the most fundamental truth about the natural world. It is never truly static, never truly finished, never at a permanent equilibrium. The forces that drive change, the shifting of continents, the fluctuation of climates, the random innovations of evolution, operate on timescales that dwarf the experience of any individual organism or any single species. But they operate nonetheless, relentlessly and without regard for the success or the complexity or the history of the creatures that have thrived under the previous conditions. And for the terror birds, the most consequential of these changes was geological in nature, a slow, inexorable process that would eventually connect their island continent to the broader world in a way that would transform everything they knew. The story of how South America went from isolated island continent to connected part of a larger landmass is one of the great geological stories of the last few million years of Earth history, and it is a story that had profound consequences not just for the terror birds, but for almost every living thing on both sides of the newly formed connection. For most of the terror birds' long reign, South America had been separated from North America by a substantial water barrier, a marine connection between the Atlantic and Pacific Oceans that prevented the large-scale exchange of terrestrial animals between the two continents. The Caribbean islands provided some stepping stones across which certain types of organisms could occasionally make the crossing, but these were not routes available to large terrestrial animals. The terror birds could not fly across the gap. The large mammals of North America could not swim across it. The two continents were developing their faunas in relative isolation from one another, each pursuing its own evolutionary path. But deep beneath the surface of the Earth, the forces of plate tectonics were working their slow, patient transformations. The tectonic plates on which the continents rest were moving, as they always are, at rates of centimeters per year that add up, over geological time, to changes of hundreds and thousands of kilometers. The plate boundary in the region between North and South America was gradually changing the geography of that area, raising the seafloor in some places and lowering it in others, slowly building what would become the land bridge known as the Isthmus of Panama. This process was not sudden. It unfolded over millions of years, with the water barrier between the continents gradually narrowing and shallowing before eventually, approximately 3 million years ago, closing entirely and creating a continuous land connection between North and South America. The exact timing of this closure has been revised somewhat by recent research, with some evidence suggesting that shallow water crossings may have been possible for some species somewhat earlier than 3 million years ago. But the fully continuous land bridge that allowed large terrestrial animals to move freely between the continents in both directions was established in the neighborhood of 3 to 2.5 million years ago. This event, which geologists and biologists call the Great American Biotic Interchange, was one of the most significant events in the recent history of life on this planet. It is comparable in its biological significance to the opening of a floodgate between two bodies of water that had been separated for a very long time. Animals that had evolved in isolation on each continent began to move, following the newly available land connection in both directions, each group entering a world it had never encountered before, competing and interacting with species it had never evolved alongside, and finding that some of the ecological assumptions that had governed its evolution were suddenly no longer valid. For the animals of South America, the arrival of North American species was a profound disruption. The herbivores of South America found themselves suddenly sharing their environment with competitors from North America, animals that had evolved different feeding strategies and that occupied some of the same ecological niches. The predators of South America, including the terror birds, found themselves facing something they had essentially never had to deal with before in any serious way: competition from other large, powerful carnivores. From North America came animals that would eventually prove to be devastating competitors for the terror birds. The ancestral lineages of wolves and other large canids made their way south across the new land bridge. Large cats, including species that would eventually evolve into the magnificent saber-toothed predators, and the large felines of the Pleistocene, began to establish themselves in South American ecosystems. These were animals that had evolved in a very different competitive environment, one that had included multiple large mammalian predators all competing with one another for prey, and they had developed hunting strategies and ecological capabilities that were, in certain important respects, different from and complementary to those of the terror birds. The hunting strategies of the large mammalian predators that entered South America were not simply superior versions of the terror bird's hunting strategy. They were different strategies, shaped by different evolutionary histories and reflecting different approaches to the fundamental challenge of finding and killing prey. Where the terror birds were primarily pursuit predators, built for speed in open environments and relying on powerful beak strikes for their killing blows, many of the large mammalian carnivores were built for different things. The large cats were and are masterful ambush predators, relying on stealth, patience, and explosive short-range acceleration rather than sustained high-speed pursuit. The wolf-like canids were endurance hunters, capable of pursuing prey over very long distances at moderate speeds, wearing down their quarry through persistence rather than raw speed. These different hunting strategies allowed the arriving mammalian predators to exploit prey animals in ways that the terror birds were not well suited for, and to do so in a wider range of environmental conditions. The large cats could hunt effectively in densely vegetated environments where the terror bird's pursuit strategy would have been ineffective. The endurance hunters could pursue prey over terrain and across distances that would have been challenging for even the fastest terror birds, and both groups of mammalian predators could utilize a wider range of prey sizes and types than the terror birds, which were constrained by the requirements of their specific killing method. But it is important not to oversimplify this story. The arrival of mammalian predators did not simply render the terror birds obsolete overnight. The terror birds were still formidable animals, still capable of hunting effectively in the environments they knew best. They were not passive victims of competition, but were active participants in an evolving ecological drama, adapting their behavior and their habitat use in response to the new pressures they faced. The decline of the terror birds was not sudden but gradual, unfolding over hundreds of thousands of years as the cumulative effects of competition, climate change, and habitat transformation slowly eroded the conditions that had allowed them to thrive. Before we follow that story of decline in detail, it is worth pausing to consider something that is easy to overlook in the grand narrative of ecological change: the individual lives of the terror birds themselves. Because for all the geological and evolutionary forces at work in this story, the terror birds were living creatures with individual experiences, individual challenges, individual moments of success and failure in their daily struggle to survive and reproduce. What was it like to be a terror bird? Obviously, we cannot know with any certainty. We cannot enter the mind or the experience of an animal that has been extinct for millions of years. But we can reason from what we know about their anatomy, their ecology, and the biology of living birds to construct a picture, however imperfect, of what their daily existence might have been like. A terror bird waking at dawn in the open grasslands of Miocene South America would have been immediately alert, its large eyes scanning the landscape for movement. Birds have excellent vision, generally superior to that of mammals in terms of both acuity and color discrimination, and the terror birds, with their forward-facing eyes providing reasonable binocular vision, would have been well equipped to spot prey at significant distances across the open terrain they inhabited. The low morning light, the hour when many prey animals are active after the cooler nighttime temperatures, would have been a hunting opportunity not to be wasted. The terror bird's movements across the landscape would have been purposeful and economical. Long-legged birds like ostriches and emus can cover enormous distances with relatively little energy expenditure per unit of distance, thanks to the mechanical efficiency of their gait. The terror birds, with leg proportions suggesting similar adaptations for efficient bipedal locomotion, were probably capable of ranging widely across their territories in search of prey without depleting their energy reserves excessively. This ability to cover large areas of landscape efficiently would have been enormously valuable in an environment where prey animals were scattered and unpredictable in their distribution. When a terror bird identified potential prey, perhaps a young nodo ungulate separated from its herd, or a smaller mammal that had failed to notice the approaching predator, the transition from efficient cruising to explosive pursuit would have been rapid. The long legs that were so effective for covering distance at moderate speed were also the legs that powered the high-speed burst necessary to close the gap between predator and prey before the prey animal could reach safety. The initial burst of acceleration in the open grassland environment where there was nothing to hide behind and nowhere to take immediate shelter would have been critical. A prey animal that could out-accelerate the terror bird in the first few seconds of the chase might escape. One that could not would quickly find itself with a rapidly shrinking head start. The killing blow, when it came, would have been delivered with precision and power. The hooked beak of the terror bird, descending with the force of those powerful neck muscles and the leverage of that enormous skull, would have been capable of delivering strikes of tremendous force to specific anatomical targets. A well-placed strike to the skull or spine of a prey animal could be immediately incapacitating, and the terror bird would have had the experience and the behavioral sophistication to target the most vulnerable anatomy of its specific prey. This kind of learned precision, the ability to identify and target the most effective striking points on specific prey species, is characteristic of experienced predators and would have been refined over the course of an individual terror bird's life through trial and error and through whatever behavioral information could be transmitted between generations. After a successful kill, the terror bird would have eaten, beginning with the most nutritionally rich parts of the carcass, as predators typically do. The powerful beak that served as a hunting weapon was also highly effective for processing food, for tearing through hide and muscle and accessing the organs and tissues beneath. And then, satiated, the terror bird would have continued its patrol of the landscape, alert for the next opportunity, the next moment when speed and power and precision could be brought to bear on an unsuspecting prey animal. This was not a gentle or a romantic existence. It was demanding, dangerous, and uncertain. Even an apex predator faces risks, from injury during hunts that go wrong to competition from others of its kind for territories and prey. Young terror birds, before they reached their full size and hunting capability, would have been vulnerable to a range of dangers that adult animals could shrug off. Even adult terror birds could be injured during hunts, and an injured predator that cannot hunt effectively faces starvation. The life of a terror bird was shaped by the same fundamental imperatives that shape the life of every predator. The constant need to find food, the constant risk of injury or death, the drives of reproduction and territorial competition, and the necessity of making sound decisions under conditions of uncertainty and urgency. These were complex animals with complex lives, and the millions of years of their existence were not a simple, static tableau, but a constantly shifting story of individual triumphs and failures, of populations expanding and contracting, of species adapting and evolving in response to the pressures of their changing world. They were not mere biological curiosities or prehistoric oddities. They were real creatures that lived real lives in a real world, and they deserve to be understood and appreciated in all their complexity. The fossil record of the terror birds is both extensive and fragmentary, as is typical of the fossil record of most prehistoric creatures. We have a substantial amount of material to work with, enough to reconstruct the general body plan and anatomy of many species with reasonable confidence, enough to understand something about their diversity and their geographical distribution, enough to trace the broad outlines of their evolutionary history. But we do not have a complete picture, and many of the details of their biology and behavior must be inferred rather than directly observed. The first scientific description of a terror bird fossil was published in the latter part of the 19th century, when Argentine paleontologist Florentino Aimquino began describing the remarkable fossils being discovered in the Patagonian formations of South America. Aimquino was a prolific and often controversial figure in the history of paleontology, and his descriptions of the terror birds, while containing some errors that subsequent research has corrected, established the foundation of our scientific knowledge of these animals. He named the species Phorusrhacidae longissimus in 1887, based on fragmentary material from Patagonia, and this species became the type specimen around which the entire family Phorusrhacidae was eventually organized. The discovery of additional material over the following decades and into the 20th century filled in many gaps in our understanding of the terror birds. The discovery of Kelenc and Guillermoy in Patagonia in 2007, represented by a nearly complete skull and other material, was particularly significant because it revealed the largest terror bird skull ever found and provided important information about the upper range of size within the family. The skull of Kelenkin, measuring nearly 90 centimeters in length, remains one of the most striking physical artifacts of the terror bird legacy, a concrete demonstration of the extraordinary dimensions these animals could achieve. Fossil material of terror birds has been found at numerous sites across South America, with particularly important deposits in Argentina and Brazil. The Patagonian region of Argentina has been especially productive, with multiple geological formations containing terror bird material spanning a wide range of ages. The La Venta fauna of Colombia has also produced important terror bird material, demonstrating that these animals were present in more equatorial regions as well as in the temperate south. And in a particularly interesting development, fossil material that has been attributed to a terror bird has been found in North America, specifically in Florida, suggesting that at least one species managed to make its way northward across the newly formed land bridge during the period of the Great American Biotic Interchange. This discovery of terror bird material in North America is fascinating for several reasons. It demonstrates that at least some terror birds were capable of dispersing northward in the same way that other South American animals were moving in that direction during the interchange. It shows that the terror birds were not entirely passive recipients of the changes brought about by the formation of the land bridge, but were themselves active participants in the process, capable of exploring and establishing themselves in new territories. And it raises interesting questions about how those northward dispersing terror birds would have interacted with the native predators of North America, about what the ecological consequences of their arrival might have been in a world where large mammalian predators were already well established. The North American terror bird, sometimes referred to in popular accounts as Titanes walleri, appears to have been a large species, perhaps comparable in size to some of the bigger South American forms. Its presence in Florida, as evidenced by fossil material that has been dated to roughly 2 to 5 million years ago, represents one of the most intriguing chapters in the terror bird story, a brief excursion beyond the homeland of the family into a completely different ecological context. Whether this northern population of terror birds was successful in the long term, whether it established itself as a significant predator in the North American ecosystems it entered, or whether it was a short-lived experiment that ultimately did not persist, remains somewhat uncertain. The fossil material from Florida is not sufficiently abundant to answer these questions with confidence. But the very existence of this northward dispersal tells us something important about the terror birds as organisms. They were not simply creatures locked into a single environment, incapable of movement or exploration. They were, or at least some of them were, capable of dispersing into new territories and surviving, at least for a time, in conditions quite different from those in which the family had evolved. This speaks to a degree of ecological flexibility that is important to keep in mind when considering the larger story of their eventual extinction. The climate of South America during the long reign of the terror birds was not constant. It changed repeatedly and dramatically over the millions of years of the Cenozoic Era, shifting between warmer and cooler periods, between wetter and drier conditions, and reorganizing the distribution of habitats and the composition of ecological communities in ways that had significant effects on both predators and prey. During some periods, South America's climate was warmer and more humid than today, with dense forests covering larger areas of the continent. During other periods, the climate was cooler and drier, with grasslands and open savannas expanding at the expense of forests. The Miocene epoch, which roughly spans the period from 23 to 5 million years ago, and which was in many ways the golden age of terror bird diversity and abundance, saw significant climatic variability, including a general trend toward cooler and drier conditions as the epoch progressed. These climatic changes were consequential for the terror birds because they affected the distribution and abundance of their preferred habitats. The expansion of open grasslands during cooler, drier periods was in many ways favorable for the terror birds, providing more of the open terrain that suited their hunting style and potentially supporting larger populations of the herbivorous prey animals that sustained them. But periods of increased aridity that went too far, that reduced the overall productivity of the landscape and diminished the prey populations that the terror birds depended on, would have created significant challenges. The Pliocene epoch, which followed the Miocene and which spanned roughly from 5 to 2.5 million years ago, was a period of significant global cooling and the beginning of the cycle of glaciations that has characterized the Pleistocene epoch, the last 2.5 million years of Earth history. This cooling trend had profound effects on South American ecosystems, reshuffling the distribution of habitats and altering the composition of ecological communities in ways that created new challenges for established predators. And it was during the Pliocene, roughly coinciding with the period of the Great American Biotic Interchange, that the terror birds began their final decline. It would be overly simplistic to attribute this decline to any single cause. The reality was a convergence of multiple factors, each of which contributed to the erosion of the ecological conditions that had sustained the terror birds for tens of millions of years. Climate change was one factor. The arrival of new competitors was another. The transformation of habitats as North American flora and fauna established themselves in South America was a third. And the loss of the specific prey animals that the terror birds had evolved to hunt, as those prey species faced their own challenges from the changing environment and from competition with North American immigrants, was perhaps the most immediately devastating factor of all. The story of the terror bird's decline is a story of accumulating disadvantages, of a world that was gradually becoming less and less suited to the specific ecological requirements of these remarkable animals. It is not a story of sudden defeat or dramatic overthrow. It is a story of slow erosion, of the gradual narrowing of the circumstances under which the terror birds could thrive, until those circumstances became too rare and too limited to sustain viable populations. But before we follow that story to its conclusion, we need to understand in more depth what the arrival of the North American predators actually meant for the ecological dynamics of South America, because this is one of the most important chapters in the terror bird story and one that is easily misunderstood. When we talk about the arrival of wolf-like predators and big cats in South America, we are talking about animals that brought with them not just different anatomical capabilities, but different evolutionary histories, different behavioral repertoires, and different ecological strategies that had been shaped by millions of years of evolution in an environment where multiple large predators coexisted and competed with one another. The large mammalian predators that evolved in North America and Eurasia did so in the context of an ecological guild of multiple competing predators. They were not, like the terror birds, the sole dominant predators of their ecosystems. They were one of several large carnivores, each occupying a somewhat different ecological niche, each with somewhat different prey preferences and hunting strategies, each competing with the others for resources in a complex web of interspecific competition. This competitive context shaped their evolution in important ways. It forced them to be flexible, to be able to exploit a range of resources, and to adjust their hunting strategies in response to the presence and behavior of competitors. It drove the evolution of behavioral sophistication and ecological versatility that made these animals more resilient to environmental change than a predator that had evolved in the absence of such competition. The wolves and wolf-like canids that entered South America were endurance hunters, animals capable of pursuing prey over long distances at speeds that, while not as fast as the terror bird's top speed, could be maintained for far longer. A prey animal that could initially outrun a terror bird might eventually tire, but an animal that could outrun a pursuing wolf-like predator would need to maintain that pace for a very long time, potentially covering many kilometers before the pursuit was abandoned. This endurance hunting strategy is effective in a wide range of environments and against a wide range of prey types, and it is relatively insensitive to the specific landscape conditions that constrain the terror bird's pursuit strategy. The big cats, by contrast, were ambush predators, relying on concealment, stealth, and explosive short-range acceleration to catch prey that was often capable of outrunning them over longer distances. This ambush strategy was particularly effective in environments with significant vegetative cover, in woodlands and forest edges and areas of tall grass, where a cat could approach prey without being detected and then launch an attack before the prey had time to react and flee. The terror birds, with their pursuit-based strategy that depended on open terrain and the ability to close the distance to fleeing prey, would have been much less effective in these denser environments. What this means is that the arriving mammalian predators were not simply better hunters than the terror birds in some absolute sense. They were hunters that could operate effectively in a wider range of ecological conditions, that could exploit prey in a wider range of environments, and that could adjust their strategies in response to the specific circumstances they encountered. The terror birds, for all their formidable capabilities, were more constrained in the range of conditions under which they could hunt effectively. They were specialists in a way that the mammalian predators were not, and specialization, as we will see, has a profound relationship with vulnerability. The arrival of these competing predators in South America did not immediately displace the terror birds from their dominant position. South America was a large continent with a wide range of habitats, and the mammalian predators needed time to establish themselves, to build up their populations, and to spread across the continent. In the early stages of the interchange, the terror birds and the new arrivals likely inhabited somewhat different ecological niches and competed relatively indirectly. The terror birds in open grassland environments would not have faced immediate, intense competition from forest-adapted ambush predators. The endurance hunters, effective as they were, would not have immediately outcompeted the terror birds in the open terrain environments where the birds excelled. But over time, over the hundreds of thousands of years that followed the formation of the land bridge, the ecological dynamics began to shift. The mammalian predators were spreading across South America, establishing themselves in more and more habitats, learning to exploit the prey animals of the continent and exerting their own selection pressures on those prey animals. The prey animals themselves were changing, with some native South American species declining or going extinct as they faced competition from North American immigrants, and with the behavior and distribution of surviving prey species shifting in response to the new predators they now faced. The prey animals that had evolved alongside the terror birds for millions of years had developed their antipredator behavior specifically in response to the terror birds' hunting strategy. They were alert to the visual and acoustic signals that indicated the approach of a large, fast, bipedal predator. They had evolved the speed and the vigilance necessary to survive in a world where a terror bird might be closing the distance at 60 kilometers per hour. But the arrival of new predators with different hunting strategies introduced new challenges for which these prey animals were less prepared. The approach of a large cat, slow and patient and concealed, was a different kind of threat that required different behavioral responses, and prey animals that had not evolved alongside such predators would have been more vulnerable to them. This vulnerability of South American prey to new predator strategies would have had indirect consequences for the terror birds. If prey populations were declining due to the combined hunting pressure of both the terror birds and the new mammalian predators, if the prey animals were being pushed into behavioral patterns that made them less available to pursuit predators like the terror birds, the hunting success of the terror birds would have been reduced even without any direct competition between the birds and the mammals. And this is perhaps the most important point to understand about the role of ecological context in the terror bird's decline. It was not simply a matter of the mammalian predators being better hunters than the terror birds in some direct, head-to-head comparison. It was a matter of the ecological conditions that the terror birds depended on, the specific configuration of prey populations, habitat types, and predator-prey dynamics that had allowed them to thrive for so long, being gradually dismantled by the cumulative effects of multiple interacting changes. The terror birds did not lose because they were weak. They did not lose because some other predator was simply better at everything they did. They lost because the specific, reliable set of conditions they required was being disrupted at multiple levels simultaneously, and because they lacked the flexibility to adapt to those disruptions in the way that the new arrivals could. This is a profound lesson from the history of life, one that resonates beyond the specific story of the terror birds. Dominance in nature is always contextual. It is always a function of the match between an organism's capabilities and the specific conditions of its environment. A creature that is perfectly suited to its world is not therefore suited to every world. The qualities that make it supreme under one set of conditions may be irrelevant or even disadvantageous under another. The terror birds were not defeated by the mammalian predators because the mammals were intrinsically superior. They were defeated because the world in which the terror bird's qualities were supreme was ceasing to exist, and the world that was replacing it rewarded different qualities. The habitats of South America were not immune to the changes brought by the Great American Biotic Interchange. North American plant species, traveling as seeds by a variety of dispersal mechanisms, began to colonize South American environments in the wake of the land bridge formation. North American herbivores, bringing with them their grazing and browsing habits, began to modify the vegetation of the regions they inhabited. And the climate itself continued to change during the Pliocene and early Pleistocene, with the onset of northern hemisphere glaciation driving global cooling and shifts in precipitation patterns that altered the character of South American ecosystems. The grasslands and open landscapes that had been the terror bird's primary hunting grounds were not eliminated. South America retains extensive grassland and open country environments to this day, but the character of those environments was changing, and the ecological communities they supported were being reshuffled in ways that did not favor the terror birds. The native South American herbivores that had been the terror bird's primary prey for millions of years were facing their own challenges, and some lineages that had been important prey species for the terror birds declined significantly or went extinct during the period of the interchange and its aftermath. The fragmentation of habitats, the breaking up of once continuous landscapes into smaller, more isolated patches of suitable terrain, was another factor that worked against the terror birds. Large predators generally require large territories to sustain themselves, and they are sensitive to the kind of habitat fragmentation that reduces the amount of suitable hunting ground available to them. When continuous expanses of open grassland are broken up by expanding forests or by the presence of competitors that displace the predator from portions of the landscape, the effective hunting area available to a predator decreases, and with it the number of prey encounters and the reliability of finding sufficient food. The concept of reliable conditions is crucial to understanding the terror bird's decline. A predator can survive in a challenging environment if the challenges are predictable and if it has the behavioral and physiological flexibility to cope with them. But when the challenges become unpredictable, when the conditions that allow successful hunting are present sometimes but not others, when the prey is available in sufficient quantity in some places but not others, the predator faces a qualitatively different kind of challenge. It is not simply a matter of working harder to find food. It is a matter of the specific strategy and the specific body design that the predator is built around, not reliably delivering the results it was evolved to deliver. The terror birds were built for a world of reliable open landscapes, consistent prey populations, and the absence of serious competition from other apex predators. For most of their existence, that was the world they lived in. But as the Pliocene gave way to the Pleistocene and the world continued to change, the reliability of those conditions decreased. The open landscapes were less reliably available. The prey populations were less stable and less predictable in their distribution and behavior. The competitive landscape was more complex, with other powerful predators now sharing the ecosystem and exerting their own pressures on both prey and on the terror birds themselves. This gradual erosion of reliable conditions is what the terror birds could not adapt to quickly enough. Evolution is a powerful process, but it is not infinitely fast. It requires time, and it requires that the selection pressures driving change be consistent enough and strong enough to reshape populations across generations. The changes that the terror birds faced in the last few million years of their existence were dramatic and rapid by evolutionary standards, too rapid for the birds to evolve new strategies that might have allowed them to cope with the new conditions they faced. And so, over hundreds of thousands of years, the populations of terror birds declined. Individual species went extinct one by one, as the conditions that had allowed each species' particular variant of the terror bird lifestyle became less and less viable. The diversity of the family, which had been one of the foundations of its long-term success, gradually contracted as fewer and fewer ecological niches remained viable for these animals. The last terror birds living in the final stages of the family's existence were the remnants of what had once been a diverse and flourishing lineage, reduced to a fraction of their former abundance and diversity, clinging to whatever patches of suitable habitat remained. The exact timing of the last terror bird's extinction is not known with precision. The fossil record thins out toward the end of any lineage's history, as declining populations leave fewer individuals to be preserved in the geological record. The most recent dated fossil material of terror birds suggests that the family survived until somewhere around 2 to 3 million years ago, in the early Pleistocene, though some researchers have argued that the last survivors may have persisted somewhat later. The uncertainty in these dates is itself a reflection of the gradual, drawn-out nature of the extinction process. There was no sudden moment when the last terror bird died, but rather a long, slow fading of a lineage that had once defined an entire continent's ecological character. There is something that deserves to be said here about what extinction means, because the word is easily misunderstood, and the concept is often treated too simplistically in popular accounts of prehistoric life. Extinction is not failure. This is perhaps the most important reframing that the story of the terror birds invites us to make. The terror birds existed for somewhere in the neighborhood of 60 million years, during which time they were the dominant large predators of an entire continent. They shaped the evolution of the animals that lived alongside them. They influenced the development of the ecosystems in which they lived. They left an impression on the history of life that, while it cannot be seen directly in the modern world, is written into the evolutionary legacy of the surviving lineages that evolved in their presence. To call this failure is to fundamentally misunderstand what the terror birds were and what they accomplished in evolutionary terms. The vast majority of species that have ever existed on this earth are now extinct. Extinction is not an aberration or a sign of inadequacy. It is the normal, expected outcome for any lineage over sufficiently long periods of geological time. The question is not whether a lineage will eventually go extinct, because given enough time, virtually all will. The question is what that lineage accomplishes during the time it exists, what it contributes to the story of life on Earth, how deeply it shapes the world around it. By any reasonable measure, the terror birds were an extraordinary evolutionary success. They were large, powerful, ecologically dominant predators that thrived for an almost incomprehensibly long period of time. Their reign was longer than the entire history of the modern horses, longer than the tenure of the saber-toothed cats, longer than the duration of many of the most iconic lineages in the history of life. If we judge them by the standard of longevity, of ecological impact, of evolutionary innovation, the terror birds were among the most successful predators that have ever walked the earth. Their extinction was not a judgment on their quality as organisms. It was a consequence of the fundamental nature of the world they lived in, a world that is always changing, always becoming something different from what it has been, always creating new conditions that reward different qualities and make previously successful strategies less effective. The terror birds were not victims of their own inadequacy. They were victims, if that word is even appropriate, of geological time, of the slow, patient, unstoppable processes that reshape continents and climates and ecosystems over millions of years. This is a perspective that the fossil record, in its long and complex testimony about the history of life, invites us to adopt when we think about any extinct lineage. The dinosaurs were not failures because they went extinct. The mammoths were not failures because they went extinct. And the terror birds were not failures because they went extinct. They were, each of them, extraordinary evolutionary achievements that thrived in the specific contexts their world provided, and whose eventual disappearance was the consequence of those contexts changing in ways that no organism, however well adapted, could indefinitely withstand. As we approach the midpoint of this story, it is worth pausing to consider what the terror birds mean to us today, in a world that they left millions of years ago. Why does it matter that they existed? Why is it worth spending time understanding their anatomy, their ecology, their evolutionary history, and the story of their decline? What do these long-vanished birds have to offer to our understanding of the world or of ourselves? There are several answers to these questions, and they operate at different levels of abstraction. At the most concrete level, the terror birds are scientifically important because they represent one of the most dramatic examples of convergent evolution in the history of vertebrates, the evolution of a bird into an apex predatory role typically associated with mammals. Understanding how and why this happened, what ecological conditions allowed it, what anatomical transformations it required, and how the resulting creature functioned in its ecosystem, contributes to our understanding of how evolution works, of what is and is not possible for natural selection to achieve, and of how ecological roles shape the organisms that fill them. At a broader level, the terror birds are important as a case study in the relationship between ecological success and environmental context, in how the qualities that make a creature dominant under one set of conditions can leave it vulnerable when those conditions change. This is a lesson with implications that extend far beyond the specific case of the Phorusrhacidae. It is a lesson about the nature of adaptation, about the costs of specialization, about the relationship between resilience and flexibility in the face of environmental change. These are not abstract academic concerns. They are questions with deep relevance to understanding how living systems, including the human-influenced ecosystems of the modern world, respond to change. At the deepest level, the story of the terror birds is part of the larger story of life on Earth, a story that is still unfolding, that is still being written in the bodies and behaviors and evolutionary trajectories of every living thing on the planet today. The world that we inhabit is not a finished, static creation. It is the current chapter in a story that began billions of years ago and will continue long after we are gone. The terror birds are a reminder of that larger story, of the depth of time through which life has been evolving and changing and producing remarkable creatures, and of the fact that the world we see around us today is just one moment in that unending process. The terror birds were here. They were real, they were magnificent, they shaped a world, and then that world changed, and they could not change with it. And in their passing, they left behind something invisible but real, the imprint of their presence on the evolutionary heritage of the organisms that survived and evolved in the world they had helped to create. The prey animals whose descendants still live in South America carry in their biology the memory of millions of years of predation by these birds, an evolutionary memory written in the sharpness of their senses, the quickness of their reflexes, the social behaviors that evolved to detect and escape a danger that no longer exists but that shaped them nonetheless. This is what it means to say that the terror birds left an ecological memory. Not that any living creature remembers them in the way we might remember something, but that the evolutionary legacy of their presence persists in the biology of the organisms that shared their world, a legacy that was written over millions of years of predator-prey interaction, and that cannot be erased simply because the predator has disappeared. The history of life is not a series of separate, isolated stories. It is a single, continuous, deeply interconnected narrative in which every chapter shapes the chapters that follow. The terror birds were one of the great chapters in that narrative, a chapter of power and dominance and extraordinary evolutionary achievement, followed by a long, slow fade into the geological past. But the story did not end with them. It continued, as it always does, carrying forward the consequences of everything that had come before into a future that those long-vanished birds could never have anticipated. And it is that future, the world that came after the terror birds, and the traces of their influence that persist in it, that we will explore in the second part of this story. But for now, let us stay a little longer with the birds themselves, with the details of their biology and their ecology and their extraordinary tenure as the lords of a lost world, because there is more to say about what made them so remarkable, more to understand about the specific qualities that allowed them to dominate for so long, and more to appreciate in the simple, extraordinary fact of their existence. The terror birds occupied South America during one of the most dynamic and interesting periods in the continent's biological history. The Cenozoic Era, the age of mammals that began 66 million years ago and continues to the present, was a time of enormous biological change and diversification across the entire planet. On most continents, this era was characterized by the rise of mammals to ecological dominance, by the diversification of placental and marsupial lineages into the wide range of forms we see today. But in South America, the story was different because the isolation of the continent meant that the usual rules did not entirely apply. The fauna of Cenozoic South America was a mixture of organisms from different evolutionary origins, each adapted to the specific conditions of that isolated landmass. The native South American mammals included groups like the nodo-ungulates and litopterns that we have already mentioned, as well as the xenarthrans, which are the group that includes modern sloths, anteaters, and armadillos. These animals, particularly the xenarthrans with their remarkable diversity and ecological range, were among the most important components of the South American fauna during the terror birds' long reign. The xenarthrans produced some of the most extraordinary animals in the history of life. The ground sloths, relatives of the tree-climbing sloths of today, evolved into truly massive forms during the Cenozoic. Some species of ground sloth reached sizes comparable to modern elephants, making them among the largest terrestrial mammals that have ever existed. These enormous herbivores would not have been primary prey for the terror birds, which, despite their size and power, were probably constrained in the maximum size of prey they could effectively hunt by the biomechanics of their killing method. A fully grown giant ground sloth, weighing several tons and equipped with powerful claws, would have been a formidable and potentially dangerous opponent for even the largest terror birds. But the juvenile ground sloths, the young animals that had not yet grown into their full adult dimensions and defensive capabilities, would have been potential prey for the larger terror birds. And the various other xenarthran species, the smaller ground sloths and the ancestral relatives of modern armadillos and anteaters, were certainly within the size range that the terror birds could have hunted. The xenarthrans, in their extraordinary diversity, provided a component of the prey base that sustained South American predators across the entire Cenozoic. Nodoungulates and litopterns, the native South American hoofed mammals, were probably more important components of the terror bird's prey base for much of their history. These animals occupied the ecological roles filled by horses, antelope, cattle, and rhinoceroses on other continents, and they evolved a similar diversity of sizes and body types in response to the ecological opportunities available to them. Some were small, rabbit-sized animals. Others grew to the size of modern rhinoceroses. Most were probably relatively fast, having evolved in an environment where the terror birds were the primary large predators and speed was the primary defense. The relationship between the terror birds and the native South American hoofed mammals was one of the defining ecological dynamics of the continent for millions of years. These were the primary predators and the primary prey, the two sides of an evolutionary arms race that played out across the vast timescales of the Cenozoic. The nodoungulates and litopterns evolved their speed, their vigilance, and their social behaviors in response to predation by the terror birds. The terror birds evolved their speed, their hunting strategies, and their anatomical specializations in the context of pursuing these specific prey animals. The two groups were, in a very real evolutionary sense, shaped by each other, co-evolved in an intricate dance of predation and evasion that lasted for tens of millions of years. When the great American Biotic Interchange disrupted this relationship, when North American ungulates began to compete with the native South American hoofed mammals, and when North American predators began to hunt them using different strategies, the foundations of this long-standing ecological relationship were destabilized. The nodoungulates and litopterns, already under pressure from the new competitors for their ecological roles, found themselves additionally challenged by new predators with hunting strategies they had not evolved to evade. Many of these native South American hoofed mammal lineages went extinct during the Interchange and its aftermath, their populations unable to cope with the combination of new competitors and new predators. The loss of these prey species was a blow to the terror birds that went beyond the simple reduction of the prey base. The terror birds had evolved to hunt specifically these animals, had refined their strategies and their anatomy over millions of years in the context of pursuing specifically these prey. The arrival of North American hoofed mammals, which had their own adaptations and behaviors shaped by a completely different evolutionary context, introduced a prey resource that the terror birds were not as well equipped to exploit. The new arrivals were faster or had different escape behaviors or inhabited different microhabitats, and hunting them successfully would have required adaptations that the terror birds did not have and could not develop quickly enough to prevent the cumulative disadvantage from compounding. This mismatch between the terror birds' evolved capabilities and the changing prey landscape they faced is a crucial element of the extinction story. It is not enough to say simply that new competitors arrived. We need to understand the specific ways in which the ecology of South America changed and how those changes affected the specific requirements of the terror birds. The loss of their primary prey species, or the transformation of those prey species' populations and behaviors in response to new pressures, was probably one of the most immediately devastating consequences of the interchange for the terror birds. But let us not leave this first part of the terror bird story on a note of decline and loss. Because for the vast majority of their existence, the terror birds were not declining. They were thriving. They were the unquestioned masters of a continent. They were the creatures around which the entire ecological structure of South America was organized. They were one of the great evolutionary success stories of the age of mammals, a story that happened to unfold in feathers rather than fur. For 60 million years, these extraordinary birds defined what it meant to be a predator in South America. They were the standard against which all other predators were measured, and they exceeded that standard consistently and dramatically. They hunted the fast, alert, highly evolved prey of the South American grasslands with a combination of speed, precision, and power that made them the most feared animals on the continent. They shaped the evolution of everything around them, leaving their mark on the behavior, the physiology, and the evolutionary trajectory of every organism that shared their world. They were, in the deepest sense, magnificent, and the magnitude of that magnificence, the full measure of what the terror birds were and what they accomplished, can only be appreciated by holding in mind the extraordinary span of time across which they exercised their dominance. 60 million years, more than 60 times the duration of the entire hominid lineage, more than 600 times the span of recorded human history. Across that incomprehensible depth of time, the terror birds were present, hunting, evolving, shaping the world around them, leaving their evolutionary signature on the continent that was their home. The world that eventually rose to challenge their dominance was not a better world than the one they had thrived in. It was simply a different world, a world shaped by the collision of two previously isolated biotic communities, a world reorganized by geological forces that operated without regard for the extraordinary creatures they were displacing. The terror birds were not conquered by something that had earned that conquest through some quality that was genuinely superior to their own. They were displaced by the sheer weight of change, by the accumulation of new pressures that outpaced their capacity to adapt. That is not a story of defeat. It is a story of what life is like when you are not just an individual organism trying to survive, but a lineage embedded in a constantly changing geological and ecological world, a world that will, inevitably and repeatedly, become something other than what it has been. The terror bird story is a reminder that all dominance is temporary, all ecological success is contextual, and all creatures, no matter how extraordinary, are ultimately subject to the patient, indifferent forces of a planet that is always, at some deep level, in the process of becoming something new. Their story continues in the second part of this documentary, where we will follow the final chapters of the terror bird's existence and explore the world that came after them, a world that still carries, in its deepest ecological and evolutionary structures, the invisible memory of these magnificent, vanished birds. We left the terror birds at a turning point. For tens of millions of years, they had reigned across an isolated continent, unchallenged in their dominance, perfectly matched to the landscapes they inhabited and the prey they pursued. They had shaped ecosystems. They had driven the evolution of every creature that shared their world. They had persisted through climatic shifts and ecological reorganizations that would have overwhelmed less robust lineages. They were, by any measure, among the most successful predators in the entire history of life on Earth. But the world beneath their feet was changing. The slow grind of tectonic plates was rearranging the geography of the planet in ways that would ultimately bring an end to the isolation that had been the foundation of their success. The land bridge that was forming between South America and the continent to the north was not merely a strip of rock and soil rising from the sea. It was a corridor, a pathway along which the biological histories of two long-separated worlds would collide, interact, and ultimately reshape one another in ways that neither side could have anticipated. The terror birds did not know this. They could not know this. They went about their lives as they always had, hunting the grasslands and open woodlands, pursuing their prey with the speed and precision that had made them supreme for 60 million years. They hatched their young. They defended their territories. They grew from vulnerable juveniles into powerful adults. Each individual terror bird experienced the world as it was in that particular moment, not as it was becoming. The geological forces that would reshape their world operated on timescales far beyond the experience of any individual animal, and the changes they brought were, from the perspective of a single lifetime, almost imperceptible. But from the perspective of geological time, those changes were rapid, consequential, and ultimately devastating for the lineage that had defined South American predation for longer than most other predator lineages have existed in the entire history of life on this planet. This is the story of how those changes played out. Not as a sudden catastrophe, not as a single decisive moment, but but as a slow, drawn-out process of ecological erosion that gradually stripped away the conditions on which the terror birds depended, one layer at a time, until there was simply not enough left to sustain them. To understand the mechanics of the terror bird's decline, we need to look more closely at what was happening on the ground in South America during the critical period between roughly 5 million and 2 million years ago, the Pliocene and the earliest portion of the Pleistocene. This was the period during which the Great American Biotic Interchange was unfolding in full force, and during which the ecological character of South America was being fundamentally transformed. The formation of the Isthmus of Panama did not happen all at once. It was a gradual process, and the biological exchange between the two continents began before the land bridge was fully continuous. Islands and shallow water passages in the region between the two landmasses would have allowed some animals to cross, at least sporadically, before a fully dry, continuous connection existed. Small animals capable of rafting across narrow water gaps on floating vegetation, animals that could swim moderate distances, would have been among the earliest to make the crossing. Larger terrestrial animals, particularly those that required continuous dry land to travel, would have followed later as the bridge became more established and more passable. The biological exchange, when it came in full force, was not symmetric. It did not affect both continents equally. While animals moved in both directions, the long-term ecological consequences were quite different for the two faunas. The fauna of South America was, in general, more severely affected by the exchange than the fauna of the northern continent. Many native South American lineages declined or went extinct in the aftermath of the interchange, while many of the arrivals from the north established themselves successfully and diversified. This asymmetry has long been a subject of discussion and debate among paleontologists and ecologists. Why were the South American species, which had been so successful for so long in their isolated environment, generally less successful at coping with the interchange than their northern counterparts? The answer is complex and multifaceted, but at its core it relates to the concept of competitive context, the environmental and ecological conditions under which evolution shapes organisms and their capabilities. The fauna of the northern continent had evolved in a world of greater connectivity and greater biological exchange. Throughout the Cenozoic Era, the landmasses of North America, Eurasia, and Africa had been connected, at various times and in various configurations, by land bridges and narrow water crossings that allowed periodic exchange of species between them. The result was that the fauna of these connected northern landmasses was, in a sense, more cosmopolitan, more thoroughly tested against a wider range of competitors and ecological challenges. The predators of the northern continents had evolved in the context of multi-predator guilds, environments where multiple large carnivore species coexisted and competed. The herbivores of the northern continents had evolved under the pressure of multiple predator types, each with different hunting strategies. The result was a fauna that was, in certain important respects, more competitively robust and more ecologically flexible than the fauna that had evolved in South America's splendid isolation. This is not to say that the South American fauna was inferior in any absolute sense. The terror birds, as we have discussed at length, were extraordinary predators, and the native South American herbivores were highly successful animals that had thrived for tens of millions of years. But they had thrived in a specific context, a context characterized by the absence of the competitive pressures that shaped the northern fauna. When that context changed, when the isolation that had defined their evolutionary experience was breached, and they were suddenly confronted with competitors that brought different capabilities and different strategies, the limitations of their specialization began to become apparent. This is one of the paradoxes of evolutionary success. The very qualities that make an organism extraordinarily effective under one set of conditions can make it less effective when those conditions change. The terror birds were superbly adapted to hunting the specific prey of South America in the specific environments of that isolated continent. Their anatomy, their behavior, their entire mode of existence was finely tuned to the demands of that specific ecological context. But that fine-tuning came at a cost, the cost of flexibility. An organism that is perfectly adapted to a specific set of conditions is, by definition, less well adapted to conditions that differ from that specific set. The terror birds were not generalists, they were specialists, and specialists are always more vulnerable to environmental change than generalists. The mammalian predators that arrived from the north were, in comparison, relative generalists. Not generalists in the sense that they could eat anything or hunt anywhere, but generalists in the sense that they had evolved in a more complex, more competitive ecological context and had developed a broader range of capabilities and strategies as a result. They could adjust their behavior to different conditions. They could exploit different types of prey. They could thrive in a wider range of habitats. This flexibility, this ecological versatility, was the product of millions of years of evolution in a world where adaptability was essential for survival. The contrast between the specialists and the generalists, between the terror birds and the mammalian predators, was not immediately decisive. The terror birds could still hunt effectively in the environments they knew best. They were still formidable animals, still capable of killing prey that the mammalian predators could not easily take. But over time, as the ecological landscape of South America continued to change, the balance tilted increasingly in favor of the more flexible newcomers. Each change in climate, each shift in habitat distribution, each alteration in the composition or behavior of prey populations created new conditions that the mammalian predators could adapt to and that the terror birds could not. Let us examine more closely how the specific ecological changes of the late Pliocene and early Pleistocene affected the terror bird's ability to hunt and survive. This requires us to think about the detailed mechanics of predation, about the specific conditions that a pursuit predator like a terror bird needs in order to hunt successfully, and about how changes in those conditions would have affected hunting success and, ultimately, population viability. A pursuit predator depends on several key conditions being met in order to hunt effectively. First, it needs to be able to detect prey from a sufficient distance to initiate a pursuit before the prey animal can reach cover or safety. This requires open terrain with good visibility, conditions that allow the predator to scan large areas of landscape and identify potential targets. Second, the predator needs a clear, unobstructed path of pursuit. Obstacles like dense vegetation, rough terrain, or water bodies can break the chase and allow prey to escape. Third, the predator needs prey that responds to the chase in a predictable way, that runs in a direction and at a speed that the predator can match or exceed. Prey that behaves unpredictably, that freezes or doubles back or takes cover in dense vegetation rather than running, is harder for a pursuit predator to catch. Fourth, and perhaps most fundamentally, the predator needs there to be enough prey available in its hunting territory to support it through the inevitable failures. Not every chase results in a kill. Not every pursuit is successful. Even the most capable predator fails more often than it succeeds, and it is the average rate of success over time, not the outcome of any single hunt, that determines whether the predator can sustain itself. Each of these conditions was affected by the changes that were occurring in South America during the critical period of the terror bird's decline. The changing climate of the late Pliocene and early Pleistocene was altering the distribution of vegetation across the continent. While open grasslands did not disappear entirely, the composition and structure of plant communities were changing in response to shifting temperature and precipitation patterns. Some areas that had been open grassland became more wooded as changed rainfall patterns favored tree growth. Other areas that had been productive grassland became drier and less productive, supporting fewer herbivores and therefore fewer predators. The overall effect was a patchier, less homogeneous landscape, one in which the continuous expanses of open terrain that the terror birds depended on were less reliably available. The arrival of North American plant species further modified the vegetative landscape. Grasses from the north, trees and shrubs that were adapted to different conditions than the native South American vegetation, all contributed to the reshaping of plant communities across the continent. These changes were not catastrophic in themselves, but they were cumulative, each one slightly modifying the character of the landscape in ways that affected the animals that depended on it. The prey populations that the terror birds depended on were also changing, as we discussed in the first part of this story. The native South American hoofed mammals, the node ungulates and litopterns that had been the terror birds' primary prey for millions of years, were declining under the combined pressures of competition from northern ungulates and predation from northern carnivores. As these familiar prey species became less abundant, the terror birds were forced to rely on whatever remaining prey was available, which might include the newly arrived northern ungulates. But hunting the newly arrived prey species was not the same as hunting the prey they had evolved to pursue for millions of years. The northern ungulates had different behavioral responses to predators, different speed and agility characteristics, different habitat preferences, and different social structures. Some of these differences would have made them easier for the terror birds to catch. Others would have made them harder, but the overall effect of the change in prey composition was to reduce the predictability and reliability of hunting success for the terror birds, who were best adapted to pursuing the specific prey animals of their long evolutionary history. The cumulative effect of all these changes, the altered vegetation, the shifting climate, the changing prey base, the increased competition from mammalian predators, was a gradual but relentless reduction in the reliability of the conditions the terror birds needed to survive. It was not that any single factor was overwhelmingly destructive. It was that each factor removed a small portion of the ecological support system on which the terror birds depended, and the cumulative effect of all these small removals was eventually too great for the birds to compensate for. This is the pattern that characterizes many extinctions in the history of life, not a single dramatic blow, but a gradual accumulation of disadvantages, each one manageable in isolation but overwhelming in combination. The terror birds did not face a single existential threat. They faced a constellation of interrelated challenges, each one relatively modest, but all of them acting simultaneously and reinforcing one another in a way that the birds could not overcome. There is an important distinction to be made here between the kind of extinction the terror birds experienced and the kind of extinction that dominates popular imagination, the sudden, catastrophic event that wipes out entire groups of organisms in a geologically instantaneous moment. The mass extinction at the end of the Cretaceous period, the one caused by the asteroid impact that ended the age of the non-avian dinosaurs, is the archetype of this kind of sudden, dramatic extinction. That event was so fast, so powerful, and so overwhelming that the vast majority of large terrestrial animals on the planet were killed in a geologically brief period of time. The extinction of the terror birds was nothing like that. It was slow. It was gradual. It unfolded over hundreds of thousands of years, perhaps millions of years, depending on how one defines the beginning and end of the process. Individual species within the Phorusrhacidae went extinct at different times, some earlier and some later, as the specific conditions that sustained each species were eroded at different rates in different parts of the continent. The family as a whole did not go extinct in a single event, but rather in a prolonged process of attrition, species after species disappearing as the ecological niche it occupied became untenable. This kind of extinction, the slow, gradual kind, is actually far more common in the history of life than the sudden, catastrophic kind. Most extinctions are not the result of asteroid impacts or volcanic mega-eruptions. They are the result of the ordinary, ongoing processes of ecological and environmental change, processes that operate continuously and that are constantly reshaping the conditions under which organisms must survive. Species go extinct when the conditions they depend on change faster than they can adapt, when the match between their capabilities and their environment degrades to the point where they can no longer sustain viable populations. The terror bird's extinction was this kind of ordinary, gradual extinction, despite the extraordinary nature of the animals involved, and it is worth emphasizing how unusual this is from the perspective of their own remarkable history. For 60 million years, the terror birds had weathered every climatic shift, every environmental change, every ecological disruption that South America had experienced. They had survived through enormous spans of time during which the climate changed dramatically, during which habitats expanded and contracted, during which prey species evolved and went extinct and were replaced by new ones. They had been, for that entire immense span of time, resilient enough to persist through everything the world threw at them. What changed in the Pliocene and Pleistocene was not that the challenges became greater in any single dimension. What changed was that the nature of the challenges became fundamentally different. The previous challenges the terror birds had faced were challenges within a closed system, challenges that occurred within the context of an isolated South America whose ecological dynamics were governed by the organisms that had evolved there together. The terror birds and their prey and their competitors and the habitats they inhabited were all parts of a single, integrated, co-evolved system, and changes within that system, while sometimes dramatic, occurred within parameters that the system was equipped to handle. The formation of the land bridge and the great American Biotic Interchange broke open that closed system. It introduced elements that were entirely external to the co-evolved ecology of South America, organisms with different capabilities and different evolutionary histories that did not fit into the established ecological dynamics, and that disrupted those dynamics in ways that the system had never experienced before. This was not a quantitative increase in the severity of challenges. It was a qualitative change in the nature of challenges, a shift from familiar, manageable disruptions to unfamiliar, destabilizing ones. And it was this qualitative change, more than any single specific factor, that the terror birds could not survive. They had evolved the ability to cope with the kinds of challenges that their isolated world generated. They had not evolved the ability to cope with challenges from outside that world, challenges that represented ecological dynamics they had never experienced and for which their evolution had not prepared them. Let us consider the specific mammalian predators that were competing with the terror birds during their final period and examine the dynamics of that competition in more detail, because the nature of the competitive interaction between the terror birds and the arriving mammalian carnivores is one of the most important aspects of this story. The large cats that entered South America were among the most important of the new competitors. The cat family Felidae had evolved in the connected landmasses of the northern hemisphere, where it had diversified into a range of forms adapted to different habitats and different prey. Some of these cats were relatively small, roughly the size of modern bobcats or lynxes. Others were much larger, comparable to modern jaguars or even larger. And some, particularly the saber-toothed cats of the subfamily Machairodontini, were among the most specialized and formidable predators the mammalian world has ever produced. The saber-toothed cats are relevant to the terror bird story, not because they directly competed with the birds for the same ecological niche, but because they represented the kind of ecological diversity and competitive pressure that the mammalian predator guild could bring to bear on a prey community. The saber-toothed cats were specialized for killing large prey, using their enormous canine teeth to deliver precise, deep wounds to the throat or neck of their quarry. They were probably ambush predators, relying on stealth and explosive power rather than sustained pursuit, and they likely targeted prey that was larger than what the terror birds typically hunted. But the presence of saber-toothed cats in South American ecosystems had indirect effects on the terror birds that went beyond simple direct competition. By hunting and reducing populations of large herbivores, the saber-toothed cats altered the composition and behavior of the prey community in ways that affected all the predators in the system. By occupying territory and maintaining their presence in certain habitats, they restricted the areas in which other predators could operate. By influencing the spatial distribution and movement patterns of prey animals, they changed the dynamics of predator-prey interactions for every predator in the system. The more conventional large cats, those that resembled modern jaguars and cougars in their ecology, were perhaps more directly competitive with the terror birds. These were versatile, powerful predators that could hunt a range of prey sizes in a range of habitats. They were effective in both open and wooded environments, capable of both ambush and short pursuit hunting strategies, and equipped with the behavioral flexibility to adjust their hunting methods to the specific conditions they encountered. In an open grassland environment, a large cat could stalk prey using whatever cover was available and then launch a short, explosive chase to close the final distance. In a wooded environment, it could use the vegetation to approach prey unseen. In either case, it was capable of hunting prey that would also have been targets for the terror birds. The wolf-like canids that entered South America presented a different kind of competitive challenge. Canids are social animals that often hunt in packs, using cooperative strategies to pursue and subdue prey that would be too large or too fast for a single individual to take. Pack hunting allows canids to target a wider range of prey sizes than their individual body size would suggest, and the cooperative nature of their pursuit strategies allows them to sustain chases over longer distances and to coordinate their movements in ways that make escape more difficult for prey animals. The endurance hunting strategy employed by many canids is particularly significant in the context of competition with the terror birds. While the terror birds were faster than most canids in a short sprint, canids could sustain their pursuit for far longer. A prey animal that escaped the initial rush of a terror bird might still fall victim to a pack of canids that followed it at a slower pace, tracking it by scent and gradually closing the distance as the prey tired. This endurance strategy allowed canids to exploit prey that could successfully evade terror bird attacks, effectively harvesting from the same prey populations through a different method. The combined effect of these multiple predator types, each employing different strategies, each capable of exploiting different portions of the prey population and different environmental conditions, was to create a competitive landscape that was fundamentally more complex and more challenging than anything the terror birds had experienced in their long history. In the isolated world of pre-interchange South America, the terror birds had been the only large terrestrial predators, free to exploit any prey species in any environment without significant competition. In the post-interchange world, they were one of several large predators, each competing for a share of the prey resource, and each affecting the prey populations and prey behavior in ways that influenced the hunting success of all the others. This increase in competitive complexity was devastating for the terror birds precisely because they were specialized for a world of low competitive complexity. Their hunting strategy was effective in a world where they were the only major predator, where prey animals had evolved their escape behaviors specifically in response to the terror bird's pursuit strategy, and where no other predator was exploiting the same prey through a different method. In a world of multiple predators with different strategies, the terror bird's specialization became a limitation, because the prey animals were now under selection pressure to develop escape behaviors that were effective against a wider range of predator types, and because the prey populations were being harvested by multiple predators simultaneously, reducing the abundance of the prey available to any single predator. There's a concept in ecology called competitive exclusion, which states that two species that occupy identical ecological niches cannot coexist indefinitely in the same environment. one will inevitably outcompete the other, either by being more efficient at exploiting the shared resource or by being more resilient to the conditions of competition. This principle, while somewhat simplified, captures an important truth about ecological dynamics. In a world of limited resources, organisms that compete directly for the same resources will eventually resolve that competition, with one competitor gaining an advantage and the other declining. The terror bird situation was more complex than simple competitive exclusion, because they did not occupy an identical ecological niche with any single mammalian predator. Their hunting strategy, their prey preferences, their habitat requirements, and their anatomical capabilities were distinct from those of the cats and the canids. In a strict ecological sense, there was some degree of niche differentiation between the terror birds and each of the mammalian predator types, which should, in theory, have allowed some degree of coexistence. But niche differentiation does not eliminate competition entirely. It reduces it, but as long as there is any overlap in the resources being exploited, there is some degree of competition, and that competition can have significant effects over long periods of time. The terror birds and the mammalian predators were not competing for exactly the same resources in exactly the same way, but they were competing for a shared pool of prey animals, a pool that was itself under pressure from multiple directions. And in this kind of diffuse, indirect competition, the advantage typically goes to the competitor that is most flexible, most capable of adjusting its strategy in response to changing conditions, most able to exploit a wide range of opportunities. The mammalian predators, with their greater ecological flexibility and their evolutionary history of competition in multi-predator guilds, were better equipped for this kind of diffuse competition than the terror birds. They could shift their prey preferences when one prey type became scarce. They could adjust their hunting strategies when conditions changed. They could exploit habitats that the terror birds could not effectively use. This flexibility allowed the mammalian predators to maintain stable or growing populations even as the ecological landscape changed, while the terror birds, constrained by their specialization, found their viable options increasingly limited. Over time, this asymmetry in flexibility translated into an asymmetry in population trajectories. The mammalian predator populations grew and spread, establishing themselves more firmly in more habitats and exploiting more of the available prey resource. The terror bird populations contracted, retreating into the remaining patches of suitable habitat where their specialized hunting strategy could still deliver adequate results. As the mammalian predators expanded and the terror birds contracted, the overlap between their ranges increased, intensifying the competition in the remaining areas where the terror birds persisted and further eroding the birds' hunting success. This is a feedback loop, a self-reinforcing process in which each increment of decline makes the next increment more likely. As the terror birds lost territory and their populations shrank, the remaining populations became more isolated from one another, reducing the genetic exchange between groups and making each isolated population more vulnerable to local environmental fluctuations. Smaller, more isolated populations are more susceptible to random events like disease outbreaks, extreme weather events, or temporary prey shortages that a larger, more connected population could weather without serious consequences. This phenomenon, known as the extinction vortex, is one of the most important concepts in conservation biology, and it describes the process by which declining populations become progressively more vulnerable to extinction as their numbers decrease. The terror birds almost certainly experienced this extinction vortex in the final stages of their history. As their populations shrank and became more fragmented, they became increasingly vulnerable to the random fluctuations and local disasters that are a normal part of any ecological landscape. A drought that reduced prey populations in one area, a disease outbreak that killed adults in a key breeding population, a particularly severe winter that reduced food availability below the minimum needed for survival. any of these events, which would have been survivable for a large, well-connected population, could have been devastating for a small, isolated remnant population already under pressure from competition and habitat loss. The decline of the terror birds was not just an ecological story. It was also a story about time, about the relationship between the pace of environmental change and the pace of evolutionary response. Evolution is capable of producing extraordinary adaptations, of reshaping organisms in profound and creative ways in response to new selection pressures. But evolution requires time, and it requires that the population experiencing the selection pressure be large enough and genetically diverse enough to produce the variation on which natural selection can act. When environmental change is slow, when it unfolds over millions of years, and the challenges it presents increase gradually, evolution can often keep pace. Organisms adapt, populations shift, new variants arise and spread through the population, and the lineage persists in modified form in the modified environment. This is the normal process of evolutionary adaptation, and it is the process that had allowed the terror birds to survive through the many climatic and ecological changes that South America experienced during their long reign. But the changes brought by the great American biotic interchange were rapid by evolutionary standards. The formation of the land bridge, the arrival of new competitors, the reshuffling of prey communities, and the concurrent climate changes of the Pliocene and early Pleistocene all occurred within a span of a few million years, a time frame that was too short for the terror birds to evolve fundamentally new capabilities in response. The birds could not evolve the behavioral flexibility of the mammalian predators. They could not evolve new hunting strategies suited to the changed conditions. They could not evolve resistance to the competitive pressures they faced. Their evolutionary trajectory, set in motion over tens of millions of years of refinement in a specific direction, could not be redirected quickly enough to meet the challenges of a rapidly changing world. This is one of the great constraints on evolutionary adaptation, the speed limit imposed by the mechanics of genetic change. Mutations arise randomly, and beneficial mutations, those that improve an organism's fitness in the face of new challenges, are rare. For a beneficial mutation to spread through a population, it must confer enough of an advantage to increase the reproductive success of individuals carrying it, and it must spread through enough generations for its frequency in the population to increase to the point where it becomes common. This process takes time, typically many generations, and in large-bodied, slow-reproducing animals like the terror birds, each generation represents many years. The terror birds, with their large body size and presumably slow reproductive rate, were particularly poorly positioned to evolve rapidly in response to sudden environmental change. Large-bodied animals tend to have longer generation times than small-bodied ones, meaning that fewer generations pass in any given period of time, and therefore fewer opportunities for new genetic variants to arise and be tested by natural selection. This is one of the reasons why large-bodied species are disproportionately vulnerable to extinction. They are less able to evolve quickly in response to rapid environmental change, and they are more likely to find themselves unable to adapt before the pressures against them become overwhelming. The smaller terror bird species, those at the lower end of the family size range, might in principle have been better positioned to evolve in response to changing conditions, given their presumably shorter generation times and potentially larger population sizes. But the smaller species faced their own challenges, including competition from the many small to medium-sized mammalian predators that were establishing themselves in South American ecosystems. The ecological space available to small terror birds was being invaded by nimble, versatile mammalian carnivores that could exploit a wider range of microhabitats and prey types, leaving the smaller terror birds with ever-decreasing options. The result was that the entire family, from the largest species to the smallest, was being squeezed from multiple directions simultaneously. The largest species were losing the open country habitats and large prey populations they depended on. The smallest species were losing the ecological niches they occupied to more flexible mammalian competitors, and the mid-sized species, the ones in between, were facing the combined effects of both types of pressure. No size class within the family was exempt from the accumulating disadvantages, and no size class was able to evolve fast enough to overcome them. It is worth taking a moment here to consider what the world looked like from the perspective of the last terror birds, the final survivors of a lineage that had once been the unchallenged rulers of an entire continent. These last survivors would have been living in a world very different from the one their ancestors had known. The open grasslands that had once stretched unbroken across vast areas of South America were now interspersed with expanding woodlands and forests. The familiar prey species that their ancestors had hunted for millions of years were gone or greatly diminished. The landscape was populated by unfamiliar animals, competitors and prey alike, that behaved in ways that did not match the expectations encoded in the terror bird's evolutionary heritage. The last terror birds would have been rare. Their populations would have been small and scattered, confined to whatever patches of suitable habitat still remained. They would have faced the challenges of finding mates across increasingly large distances, of defending territories against both other terror birds and the mammalian predators that now shared their landscape, of finding sufficient prey in environments that could no longer sustain the densities their ancestors had enjoyed. We do not know whether the last terror birds understood, in any sense that we would recognize, that they were the last of their kind. Almost certainly they did not. The concept of being the final representative of a lineage is a human abstraction, a meaning imposed by minds capable of understanding the sweep of geological time and the significance of extinction. The last terror birds would have experienced their world simply as the world, as the only world they had ever known, with all of its challenges and difficulties accepted as the normal conditions of existence. But there is something deeply affecting about the image of those last survivors, those final members of a 60-million-year dynasty, going about their daily lives in a world that was no longer built for them. Hunting with the same powerful beaks, running on the same swift legs, scanning the horizon with the same keen eyes that had served their lineage so well for so long, and finding more and more often that those magnificent tools were no longer sufficient, that the prey was not where it should be, that the landscape was not what it should be, that the world had changed in ways that made everything harder, less reliable, less forgiving, and eventually, inevitably, the last individual died. Perhaps it was old, weakened by age, and no longer able to hunt with the speed and precision its survival required. Perhaps it was young, killed by a mammalian predator before it could reach maturity. Perhaps it simply could not find food, could not find a mate, could not sustain itself in a world that no longer had room for what it was. We will never know the specific circumstances. The fossil record, for all its revelatory power, cannot tell us the story of a single individual. But the outcome is clear. The last terror bird died, and with its death, a lineage that had persisted for 60 million years came to an end. The world did not mourn. The ecosystems of South America adjusted, as ecosystems always do, filling the ecological space vacated by the bird's absence with other organisms, reshuffling the distribution of energy and resources through the food web, reaching a new equilibrium that reflected the new conditions. The mammalian predators continued to hunt. The herbivores continued to graze. The grasslands continued to wave in the wind, indifferent to the absence of the massive bipedal predators that had once patrolled them. But the terror bird's influence did not vanish with their physical bodies. It persisted, invisibly but indelibly, in the biology of the organisms that had evolved in their presence, a subtle but real legacy that continues to shape the living world in ways that most people never suspect. Let us talk now about this concept of ecological memory, because it is one of the most profound and least appreciated aspects of how ecosystems work and how the history of life shapes the present. When we look at the animals of modern South America, we see creatures that are the products of millions of years of evolution, shaped by every force and every interaction that their lineages have experienced across deep time. Every adaptation, every behavior, every physiological capability that these animals possess is the result of selection pressures that operated on their ancestors, pressures that favored certain traits and disfavored others, pressures that were generated by the specific ecological conditions of the world in which those ancestors lived. Among those ecological conditions, for tens of millions of years, was the presence of the terror birds. The prey animals that shared South America with the terror birds evolved under the constant pressure of predation by large, fast, bipedal hunters. They evolved speed because the slow were caught and killed. They evolved vigilance because the inattentive were surprised and killed. They evolved social behaviors, herding and grouping and collective alarm systems, because isolated individuals were more vulnerable than those surrounded by alert companions. They evolved acute senses because detecting the approach of a terror bird from a greater distance provided a greater margin of safety. These traits did not disappear when the terror birds went extinct. They were passed forward through the generations because they continued to provide some advantage against the mammalian predators that replaced the terror birds, and because evolutionary traits, once established, tend to persist in populations unless there is strong selection pressure against them. The modern descendants of the prey animals that coexisted with the terror birds still carry these traits, still benefit from the speed and vigilance and social behaviors that were shaped by millions of years of predation pressure from predators that no longer exist. This is ecological memory, the persistence of evolutionary adaptations that were shaped by past ecological conditions, adaptations that continue to influence the behavior and biology of living organisms long after the conditions that shaped them have changed. It is a subtle form of historical influence, invisible in the sense that it cannot be directly observed in the fossil record, but real in the sense that it measurably affects the biology and behavior of organisms alive today. The concept of ecological memory extends beyond the simple persistence of antipredator adaptations. It encompasses the broader influence that the terror birds had on the structure and dynamics of South American ecosystems over their long reign. The evolutionary trajectories of the plants, the invertebrates, the small mammals, the reptiles, and every other organism that shared the terror birds' world were influenced, directly or indirectly, by the presence of these apex predators. The distribution of vegetation was influenced by the grazing patterns of herbivores whose movements were shaped by terror bird predation. The soil ecology was influenced by the decomposition of terror bird kills. The behavior of small animals was influenced by the patterns of activity and movement of the terror birds and their prey. All of these influences are part of the ecological memory of the terror birds, the ways in which their long presence shaped the biological world around them in patterns that persist, modified and attenuated but not erased, in the ecosystems of today. When we look at the grasslands of modern South America, at the herds of animals that graze there, at the predators that hunt them and the plants that sustain them, we are looking at a world that still bears the imprint of the terror birds, a world whose current form is the cumulative product of all the interactions and influences that have shaped it across deep time, including the 60 million years during which the terror birds were the dominant force in its ecology. This is a humbling thought. It reminds us that the world we see around us is not a fresh creation, not a system that can be understood simply by examining its current components and their current interactions. It is a historical artifact, a world whose present is shaped by its past in ways that are deep, pervasive, and often invisible. Understanding the world we live in requires understanding the world that preceded it, the world of the terror birds and all the other vanished creatures that left their mark on the continuing story of life. The terror birds also left behind a different kind of legacy, one that is relevant to how we think about the broader patterns and processes of life on Earth. They are a powerful case study in the nature of evolutionary dominance, in what it means for a lineage to be the dominant force in an ecosystem, and in how that dominance relates to the environmental context in which it occurs. The terror birds teach us that dominance is not a fixed quality. It is not something that an organism possesses inherently, like a physical trait or a genetic sequence. Dominance is a relationship, a dynamic interaction between an organism and its environment that depends on the specific conditions of that environment. An organism is dominant when its capabilities match the demands of its environment in a way that no other organism can match. But that match is contingent, temporary, and subject to change whenever the environment changes. For 60 million years, the match between the terror birds and their environment was nearly perfect. Their speed, their power, their precision, their evolved hunting strategies were ideally suited to the open grasslands and lightly wooded environments of isolated South America, to the prey populations that inhabited those environments, and to the competitive landscape that was defined by the absence of other large predators. This match was the foundation of their dominance, and as long as the match held, they were supreme. But when the environment changed, when the opening of the land bridge transformed the competitive landscape, and when climate change restructured the habitats, the match between the terror birds and their world began to degrade. The capabilities that had made them dominant were still present, still impressive, still effective under the right conditions. But the conditions under which those capabilities were effective were becoming less common, less reliable, less consistently available. The terror birds did not become less capable. Their world simply became less suited to their capabilities. This distinction is crucial. The terror birds were not defeated by their own decline. They were not undone by deteriorating physical or behavioral qualities. They were undone by the shift in environmental conditions that made their unchanged qualities less effective. This is a fundamentally different kind of story from the one that popular imagination tends to construct around extinction, which often implies that extinct animals must have been somehow deficient, somehow lacking in some quality that would have allowed them to survive. The terror birds lacked nothing. They were to the very end magnificent animals, superbly equipped for a specific ecological role. What they lacked was a world that still needed them to fill that role. This insight has implications that extend well beyond the specific case of the terror birds. It applies to any consideration of evolutionary success and failure, of dominance and extinction, of the relationship between organisms and the environments they inhabit. No organism is dominant in a vacuum. No lineage is inherently superior to all others under all conditions. Every evolutionary success story is a story about a specific match between a specific organism and a specific set of environmental conditions, and every extinction story is a story about the degradation of that match. The history of life is not a story of progress, not a narrative of steady improvement from simpler to more complex, from worse to better, from unsuccessful to successful. It is a story of fit, of the constantly shifting alignment between organisms and their environments, an alignment that is always temporary and always subject to change. The terror birds were not replaced by something better in any absolute sense. They were replaced by something that was a better fit for the conditions that happened to prevail after the interchange, just as they themselves had been a better fit for the conditions that prevailed before it. This is a perspective that can be difficult to internalize because we are accustomed to thinking about the history of life in terms of winners and losers, of superior and inferior, of animals that were advanced and animals that were primitive. But these categories do not really apply to the actual history of life. Every organism that has ever existed was advanced for its time and place. Every organism was a product of millions of years of evolutionary refinement, a solution to the specific problems posed by a specific ecological context. The terror birds were not primitive. The mammalian predators that replaced them were not advanced. Both were the products of long and complex evolutionary histories, each perfectly adapted to the specific conditions that shaped them. The only real question is whether those specific conditions will persist. And the answer over geological timescales is always no. The story of the terror birds intersects with another fascinating chapter in the history of life on Earth, the broader story of large flightless birds and the ecological roles they have played across different continents and different time periods. The terror birds were not the only large flightless birds to evolve in the aftermath of the dinosaur extinction. On other continents in other times, other lineages of birds also grew large, lost the power of flight, and occupied ecological roles typically associated with mammals. In some cases, these birds evolved into herbivores, like the elephant birds of Madagascar and the moas of New Zealand, growing to enormous sizes on islands where large mammalian herbivores were absent. In other cases, they evolved into predators, though none achieved the sustained ecological dominance that the terror birds maintained in South America. The dromornithids, sometimes called the thunder birds or demon ducks, were a family of large flightless birds that lived in Australia from the late Oligocene to the late Pleistocene. Some of these birds were enormous, rivaling the terror birds in size, and there has been considerable debate about whether they were herbivores, predators, or omnivores. The gastornithids, large flightless birds that lived in Europe and North America during the early Cenozoic, were once thought to be predatory, but are now generally considered to have been herbivores. The secretary bird and the seriemas of modern South America are sometimes cited as the closest living relatives of the terror birds, though the exact relationships among these groups remain a subject of ongoing research. What is clear from this broader survey of large flightless birds is that the evolution of large, ecologically significant flightless birds from smaller, flying ancestors is not a unique or isolated phenomenon. It is a pattern that has recurred repeatedly across different lineages and different continents throughout the Cenozoic era. Wherever ecological opportunities existed for large terrestrial birds, wherever there was an absence of competition from large mammals or other vertebrates, birds evolved to fill those opportunities, sometimes growing to extraordinary sizes and occupying ecological roles that we typically associate with mammals. The terror birds were the most successful of these large flightless bird lineages in terms of their longevity, their ecological dominance, and the sophistication of their predatory adaptations. They represent the fullest expression of a recurring evolutionary theme, the capacity of birds, given the right ecological conditions, to become the dominant large terrestrial organisms of their environments. This capacity is rooted in the avian heritage itself, in the bipedal stance, the efficient respiratory system, the keen senses, and the behavioral complexity that birds inherited from their dinosaurian ancestors, and that can, under the right circumstances, be shaped by evolution into something truly formidable. The terror birds, in this sense, were not an anomaly. They were an expression of evolutionary potential that is inherent in the avian lineage, a potential that has been realized to varying degrees at various times and places throughout the history of life since the end of the Mesozoic era. They were the most impressive realization of that potential, but they were not its only expression, and the fact that similar evolutionary trajectories have occurred independently in different lineages on different continents tells us something important about the fundamental nature of evolution. That given similar ecological opportunities, evolution tends to produce similar solutions, a phenomenon known as convergent evolution that reveals the deep, underlying regularities in the way life responds to the demands of its environment. The disappearance of the terror birds left an ecological void in South America that was not filled by any single replacement. The ecological role they had occupied, that of a large, fast, pursuit-based predator specializing in open country prey, was not taken over by any other single species or lineage. Instead, it was diffused across the various mammalian predator species that now occupied the landscape, each of which filled a portion of the ecological space the terror birds had once monopolized, but none of which replicated their specific combination of capabilities. The jaguars became the dominant ambush predators of the region. The pumas became the versatile, medium-sized generalists. The maned wolves of the open grasslands developed their own distinctive ecology, though they were primarily omnivores rather than the pure carnivores the terror birds had been. The various other carnivores that established themselves in South American ecosystems each carved out their own ecological niche, creating a multi-species predator guild that was more complex, more diverse, and more flexible than the system the terror birds had presided over, but that was also fundamentally different in character. This transition from a single dominant predator to a multi-species predator guild is itself an interesting ecological phenomenon. It reflects the different ecological styles of the organisms involved. The terror birds, as the sole dominant large predator, had occupied a very broad ecological niche, hunting across a wide range of conditions and targeting a wide range of prey sizes. This broad niche occupation was possible because they had no competitors with whom they needed to share ecological space. The mammalian predators, arriving in an environment that already contained other predators, were forced to partition the available ecological space more finely, each species specializing to some degree in specific prey types, specific habitats, or specific hunting strategies. The result was an ecosystem that was, in some respects, more resilient than the one the terror birds had presided over. A multi-species predator guild is less vulnerable to the loss of any single species, because the functions performed by one predator can be partially compensated for by the others. If one predator species declines, the others can expand into the ecological space it vacated, at least partially. This kind of functional redundancy is a form of ecological insurance, a buffer against the loss of any single component of the system. By contrast, the system that the terror birds had presided over was more vulnerable in this regard. If the terror birds declined, there was no other predator to take their place, because they had been the only large predator in the system. The ecological functions they performed, the regulation of prey populations, the shaping of herbivore behavior, the trophic cascade effects that flowed from their presence, would have been disrupted in their absence in ways that could not be compensated for by any other organism. This vulnerability of single dominant predator systems is another important lesson from the terror bird story. Ecosystems that depend on a single keystone species are inherently more fragile than ecosystems where the keystone functions are distributed across multiple species. The terror bird's long reign was made possible by the specific conditions of isolated South America, conditions that allowed a single predator lineage to monopolize the apex predator role. But this monopoly, while it made the terror birds extraordinarily successful, also made the system they presided over more vulnerable to any disruption that specifically targeted them or the conditions they depended on. When the disruption came in the form of the Great American Biotic Interchange and the concurrent environmental changes of the late Pliocene, the system could not compensate. There was no backup predator to maintain the ecological functions the terror birds had performed. There was no redundancy in the system, no alternative pathway through which the regulation of herbivore populations and the shaping of ecological dynamics could be maintained. The terror bird's decline was therefore not just a loss for the birds themselves. It was a transformation of the entire ecosystem, a shift from one kind of ecological organization to another, from a system dominated by a single specialized predator to a system regulated by a guild of diverse, flexible generalists. The world that emerged after the terror birds is the world we recognize, more or less, as the South America of the recent past and the present. It is a world of jaguars and pumas, of tapirs and peccaries, of anacondas and caimans, of the extraordinary biological diversity of the Amazon basin and the sweeping grasslands of the Pampas and the Cerrado. It is a world that functions very differently from the one the terror birds presided over, a world organized around different ecological principles and different patterns of predator-prey interaction. But it is not a world that has forgotten the terror birds. Their presence is woven into the deep structure of South American ecology in ways that are subtle but real. The heightened vigilance of South American herbivores, their tendency to be alert and quick to flee, their social behaviors that facilitate the detection of approaching predators, all of these traits were shaped in part by the millions of years during which the terror birds were the primary threat they faced. The speed of the guanacos that roam the Patagonian steppe, the wariness of the capybaras that gather near waterways, the flocking behaviors of the rheas that stride across the grasslands, all of these carry in their deep evolutionary origins the influence of predators that vanished millions of years ago. The rheas, the large flightless birds of South America that are among the terror birds' closest living relatives, occupy a fascinating position in this story. They are not predators. They are herbivores and omnivores, filling a very different ecological role from the one the terror birds occupied. But they are large, they are flightless, and they are birds, and they represent a surviving branch of the broader evolutionary tree from which the terror birds also emerged. When we watch a rhea running across the grasslands of South America with its long legs and its rapid, ground-covering stride, we are looking at a distant echo of the terror birds, a surviving expression of some of the same evolutionary tendencies that produced those formidable predators millions of years ago. The sariemas, smaller birds that live in the grasslands and woodlands of South America, are also sometimes discussed in connection with the terror birds, though the exact nature of their evolutionary relationship to the Phorusrhacidae is debated. Sariemas are ground-dwelling birds that are notable for their predatory behavior, using their beaks to kill small prey by striking them against the ground, a behavior that has been compared, perhaps fancifully, to the hunting strategy of the terror birds on a much smaller scale. Whether this behavioral similarity reflects a genuine evolutionary connection or is simply a coincidence of convergent evolution is unclear, but it adds a fascinating dimension to the story of the terror bird's ecological legacy. As we approach the conclusion of this story, it is worth reflecting on the broader lessons that the terror birds offer us about the nature of life on Earth, about the processes that shape the living world, and about the meaning of the vast sweep of evolutionary time that separates us from these extraordinary animals. The first and perhaps most fundamental lesson is about the nature of time itself. The terror birds existed for 60 million years. That number is easy to write and easy to read, but it is almost impossible to truly comprehend. Human civilization in its entirety spans perhaps 10,000 years, a figure that seems impressive until it is set against 60 million. The entire history of our species, Homo sapiens, covers perhaps 300,000 years. The entire history of the genus Homo covers perhaps 3 million years. The terror birds were already ancient, already the products of tens of millions of years of evolution, when the first members of our genus were taking their initial, tentative steps on a distant continent. This depth of time changes the way we need to think about success and failure in the natural world. From the perspective of a human lifetime, or even the perspective of human civilization, the terror birds are extinct, which might seem to imply failure. But from the perspective of geological time, their 60 million year run was an extraordinary achievement, a performance of sustained ecological dominance that very few lineages in the history of life have equaled. The terror birds were not failures. They were one of the great success stories of the Cenozoic Era, a story that happened to end, as all stories eventually do, when the conditions that sustained it changed beyond the capacity of the lineage to adapt. The second lesson is about the nature of ecological change. The world is not static. It is always in motion, always in the process of becoming something different from what it has been. The forces that drive this change, tectonic movements, climate cycles, the endless creativity of evolution, operate continuously and relentlessly, regardless of the wishes or the welfare of the organisms that depend on the current state of affairs. No ecological condition is permanent. No environmental equilibrium is stable over geological timescales. Every arrangement of organisms and environments that exists at any given moment is a temporary configuration, a snapshot of a process that is always moving toward the next configuration. The terror birds thrived for as long as the configuration suited them. When it changed, they could not change with it, and they faded from the world. This is not a tragedy in the dramatic human sense. It is simply the way life works, the way it has always worked, across the billions of years that life has existed on this planet. The terror birds were not cheated by their extinction. They were not robbed of something they deserved. They were subject to the same fundamental processes that govern all life, the same relentless cycle of adaptation and change and eventual displacement that has shaped the story of every lineage that has ever existed. The third lesson is about the relationship between specialization and vulnerability. The terror birds were extraordinary specialists, animals whose anatomy and behavior had been refined over millions of years to an exquisite degree of efficiency for a specific ecological role. This specialization was the source of their dominance. It made them the best at what they did, so good that no other organism in their world could challenge them. But it also made them vulnerable, because the very precision of their adaptation to a specific set of conditions meant that they were poorly equipped to cope with conditions that differed from that specific set. This trade-off between specialization and flexibility is one of the fundamental dynamics of evolution. Specialization offers short-term advantage, the ability to outcompete others in a specific ecological context. But flexibility offers long-term resilience, the ability to cope with the inevitable changes that will eventually transform that context. The organisms that persist the longest in the history of life are often not the most specialized but the most flexible, the ones that can adjust to changing conditions and exploit new opportunities as they arise. The terror birds were at the extreme of specialization. They were the masters of their specific world, but they were masters of only that world. When it changed, their mastery became irrelevant, and the organisms that replaced them were those that had traded some degree of specialization for a broader capacity to adapt. The fourth lesson is about interconnection, about the way that every organism is embedded in a web of relationships with other organisms, and with the physical environment, relationships that are deeply interdependent and that cannot be disrupted without consequences that ripple through the entire system. The terror birds were not isolated entities existing in a vacuum. They were nodes in a complex ecological network connected to their prey, their habitat, their competitors, and every other organism in their ecosystem by a web of interactions that shaped the behavior and the evolution of all the participants. When the terror birds declined and disappeared, the consequences of their absence were felt throughout that network. Prey populations changed in the absence of their most important predator. Habitat structures shifted in response to the altered grazing patterns of herbivores no longer under the same predation pressure. Other predators adjusted their behavior and their prey preferences in response to the ecological space vacated by the birds. The entire system reorganized itself around the absence of a creature that had been central to its functioning for millions of years. This interconnection is not unique to the terror bird story. It is a universal feature of ecological systems, a fundamental truth about the way life is organized on this planet. Every organism is connected to every other organism in its ecosystem, and the removal or addition of any single organism has consequences that extend far beyond the direct effects on that organism's immediate interactions. This is the lesson of ecology, the lesson that the terror bird story teaches with particular clarity and force. There is one final aspect of the terror bird story that deserves attention, and it is perhaps the most philosophically rich of all. It is the question of what the terror bird story tells us about the nature of dominance itself. We often think of dominance in nature as a quality that is earned and maintained through some combination of power, intelligence, and adaptability, a quality that the dominant organism possesses and that lesser organisms lack. This view is deeply ingrained in popular conceptions of the natural world, where animals are ranked on a hierarchy from the most powerful and dominant at the top to the least powerful and most subordinate at the bottom. But the terror birds story challenges this view. The terror birds were dominant not because they possessed some inherent quality of superiority, but because the specific conditions of their world aligned with their specific capabilities in a way that gave them an advantage over all other organisms in their ecosystem. Their dominance was not a quality they possessed. It was a relationship between them and their environment, a relationship that depended on the maintenance of specific conditions, and that was dissolved when those conditions changed. Dominance in nature is always like this. It is always contextual, always contingent, always dependent on the specific configuration of organisms and environments that exists at a particular moment in time. The lion is dominant in the African savanna, but it would be helpless in the open ocean. The great white shark is dominant in coastal waters, but it would be helpless on dry land. The terror bird was dominant in the open grasslands of isolated South America, but it was ill-equipped for the complex, multi-predator world that emerged after the great American Biotic Interchange. There is no creature that is dominant in all contexts, no organism that is the best at everything under all conditions. Dominance is a product of context, and context is a product of history, of the specific sequence of events and processes that created the particular set of conditions that exist at any given moment. The terror bird's dominance was the product of South America's isolation, of the absence of large mammalian predators, of the development of open grassland habitats, of the evolution of specific prey species with specific behaviors and capabilities. Remove any of these contextual factors, and the terror bird's dominance would have been impossible. This understanding of dominance as contextual and provisional rather than absolute and permanent is one of the most important insights that the natural world offers us. It reminds us that success is not a fixed state, but a dynamic relationship, always subject to the changes that are an inherent and unavoidable feature of the world we inhabit. It reminds us that the qualities that make an organism or a lineage successful at one moment in time are not the same qualities that will necessarily make it successful at another. It reminds us that the history of life is not a story of steady progress toward some ultimate goal, but a story of constant change, constant adaptation, constant reorganization in response to a world that is itself constantly changing. The terror birds understood this in the only way that an organism can understand it, through the experience of living it. They thrived when the world suited them, and they faded when it did not. Their story is complete, their lineage ended, their physical presence in the world gone forever. But the lessons their story offers about specialization and flexibility, about dominance and vulnerability, about the nature of ecological change and the meaning of evolutionary time, these lessons remain as vital and as relevant as ever. And so we come to the end of the terror bird story, or at least to the end of the part of their story that can be told through the evidence of the fossil record and the tools of scientific investigation. But in another sense, the terror bird story has no end, because the consequences of their existence continue to unfold in the living world, in the behaviors and adaptations of the organisms that evolved in their shadow and that continue to carry the imprint of that coexistence in their biology. Every time a herd of guanacos lifts its collective head at the sound of an approaching predator, every time a capybara dives for the water at the first hint of danger, every time a rhea runs across the grassland with its long legs eating up the ground in powerful strides, the terror birds are present, not as physical entities but as evolutionary influences, as shaping forces that help to create the world we see today. Their story is woven into the fabric of South American ecology in ways that cannot be removed or erased because they were a part of that fabric for 60 million years, and 60 million years of evolutionary influence does not simply vanish when its source disappears. The terror birds were real. They were magnificent. They were the product of one of the most remarkable evolutionary experiments in the history of life on this planet. An experiment in what happens when birds are given the opportunity to become the dominant large predators of an entire continent, free from the competition of the powerful mammalian carnivores that dominated other landmasses. The result of that experiment was an animal of extraordinary power, speed, and precision, an animal that was one of the most successful predators in the history of terrestrial vertebrates, an animal that shaped the evolution of an entire continental fauna over an almost incomprehensible span of time. And then the conditions changed and the experiment ended. Not with a dramatic catastrophe, not with a single decisive event, but with a long, slow fading, a gradual loss of the specific, reliable conditions on which the experiment had depended. The terror birds did not fail. The world simply became something different from what they needed it to be. Their story is a reminder of the depth of time that lies behind the world we inhabit. It is a reminder of the extraordinary diversity of life that this planet has produced over its long history. It is a reminder of the impermanence of all ecological arrangements, of the provisional nature of all dominance, of the constant, patient, unstoppable process of change that reshapes the living world across millions and billions of years. And it is a reminder that the history of life is not a ladder, not a hierarchy of better and worse, not a march of progress from primitive to advanced. It is a tide, a continuous, layered, constantly shifting tide of organisms rising and falling, adapting and declining, shaping and being shaped by the world around them in an endless, intricate, beautiful process that has been running for billions of years, and that shows no sign of stopping. The terror birds were one wave in that tide, a magnificent wave, a powerful wave, a wave that lasted for 60 million years and that left its mark on every wave that followed. But like all waves, it eventually receded, giving way to the next surge, the next reshuffling, the next chapter in the endless story of life on Earth. They are gone now, but they were here, and the world remembers. The grasslands of modern South America still stretch wide under open skies. The wind still moves through the tall grasses, and the sun still rises and sets over a landscape that has been home to extraordinary creatures for hundreds of millions of years. If you stand in those grasslands today and look out across the horizon, you will see a world that appears timeless, a world that seems as if it has always been exactly as it is. But it has not. Beneath the surface of the present, beneath the appearance of permanence and stability, lies a history of change so profound and so extensive that it makes the present moment look like what it truly is. A fleeting instant in an ongoing story, a single frame in a film that has been running for billions of years. The terror birds were part of that story. They were a chapter that lasted for 60 million years, a chapter of power and grace and extraordinary evolutionary achievement. And when that chapter ended, when the last terror bird took its last breath in the lineage that had defined South American ecology for longer than the age of mammals vanished from the earth, the story did not end. It continued, as it always does, carrying forward into the future the consequences of everything that had come before. The terror birds are gone, but their legacy endures, in the speed of the prey animals that evolved to flee them, in the structure of the ecosystems they helped to build, in the patterns of behavior and adaptation that they shaped over millions of years of predator-prey interaction. In the very idea of what it means for a creature to be perfectly suited to its world, and of what happens when that world inevitably, inexorably, becomes something else. They were the lords of a lost world. They were the greatest avian predators the earth has ever known. They were the terror birds, and this has been their story.